Hello everyone, I'm Sudeep, an embedded software developer at Espressif.
And I'm Annie, HR Manager at Espressif. Welcome back to Day 2 of Espressif DevCon24. Just like yesterday, we are broadcasting live from our Brno office in Czech Republic.
We had a power-packed Day 1 with some amazing talks covering a range of interesting topics. If you missed the first day, don't worry, we have you covered. You will find the link to yesterday's stream in the chat, and of course you can visit our conference page at devcon.espressif.com. And do not forget to like and subscribe to our YouTube channel so that you don't miss any of these amazing talks. So Annie, how are you? And how was the DevCon for you yesterday?
Sudeep, thank you so much for the question. It was incredible, and I thank you all for having me today here so I can be part of it. But as well, today's lineup is just as exciting. I love how our speakers are in various parts of the world, far away from each other, but technology brings us closer. We have got 10 amazing talks lined up today, including a keynote that you do not want to miss. Each talk will take around 30 minutes with a 5 minutes live Q&A session right after the presentation. Some QA will happen right here in the chat, and tomorrow, at the end of the Day 3, there will be an extended live Q&A session where we will try to answer all the questions left during the DevCon. Sudeep, please let us know who is the first speaker of the day, and I will give you a hint, he's one of my favorite persons.
Sure, Annie. Folks, if you've been working with ESP-IDF, maybe you've had some of these questions. How does the ESP-IDF build system work? Or how can I integrate my CMake project with IDF? Or how do I manage component dependencies? If so, don't worry, we have Ivan Grokhotkov, VP of Software Platforms from Espressif here for the rescue. Ivan is going to do a deep dive into ESP-IDF build system. He will talk about customizing your projects, managing dependencies, and unlocking some advanced features which most of us barely scratch the surface of. So, if you want to make your development process more powerful, this talk is a must-see. Let's not keep you waiting any longer. Here is Ivan to show us how it is done.
Hi everyone, my name is Ivan Grokhotkov. I'm VP of Software Platforms at Espressif. My talk today is about ESP-IDF build system. Last year, in the talk about developing and publishing ESP-IDF components, I have already touched upon some of the topics related to the build system. This year, I want to focus more on the project structure, the configuration process of ESP-IDF projects, and an important topic about the component requirements. I will also give you practical suggestions on how to solve common tasks with the ESP-IDF build system. Let's begin. Here is the plan of today's talk. The first part is the introduction. I will tell about the terminology and some of the basics of the build system. Then the main part, it's a walkthrough. We will create an ESP-IDF application and pay attention to the build system related topics. I will explain how certain things work in the build system. And the final part is a set of recipes that you can apply to your projects. The slides of this talk are available online over at this link. You can also scan the QR code to get there. I have many links in the slides, so if you're following along, I suggest opening the slides so you can click on the links. Let's go to part 1. And first I want to tell what I want to achieve with this talk. When we talk to customers, we hear some of the common questions. Some of them are related to the build system. And typically, those are the questions about structuring the projects, using the build system correctly and effectively, getting the most out of it. I hope that by the end of the talk, if you have already used the ESP-IDF build system, some of those things will become more clear to you. If you haven't used the ESP-IDF build system yet, then I hope this talk gives you enough information to get started comfortably. Here are some basics about the build system. The IDF build system compiles applications which consists of components. Component is the name of library in an ESP-IDF application. Components can be either part of ESP-IDF itself, they can be part of the application project, so developed by application developers, and also come from different other sources, from third parties. Aside from compiling the code, ESP-IDF build system also configures the program based using a system which is based on kconfig. I will explain this compile time configuration flow in a bit. ESP-IDF build system also generates IDF-specific artifacts such as partition tables, linker scripts, bootloader, and so on. And there is integration with interactive tools, such as tools for configuration, let's say menu config, flashing tools, serial monitor, debugging, and emulation tools. And finally, IDF build system is able to download components from ESP component registry, giving you access to hundreds of components developed by Espressif and third parties, and eventually saving you time when developing your project. How do different parts of ESP-IDF build system relate to each other? The build system itself is written in CMake, and when you run the build process, you typically invoke either the command line interface IDF-PI or one of the IDE extensions. Those extensions they call CMake, and CMake in turn executes the CMake list file inside the application, and that in turn executes the CMake list files inside ESP-IDF. Finally, CMake, based on all those CMake list files, generates the build script, and the build script is executed by another tool, typically by Ninja or by GNU Make. During this process, at various steps, the build system will call the cross-compiler or some of the IDF-specific tools. This happens quite in the background. What we will focus on today is the part of the build system that is implemented in your project. So the CMake list files that you write in the application project, we will not talk much about what happens inside the CMake list files inside ESP-IDF, so the underlying implementation. Also, before we start the main part of the talk, I want to talk a bit about why we have this talk specifically about IDF build system rather than just about modern CMake. To explain this, I have to go a bit back to the time when ESP-IDF didn't use CMake build system, and up until version 4, IDF was using a build system based on GNU Make. Here are what the make files written for GNU Make look like. You see that there is very little boilerplate, which means that for the make files to be that simple, there has to be a lot of implicit behavior. And when we were developing this CMake-based build system for IDF 4.x, we took a lot of that style from the GNU Make build system to ease the transition from GNU Make to CMake for existing users. Therefore, the CMake-based build system that we introduced, it also contains a lot of implicit behavior, which is intended to simplify the make files that we write as much as possible. Internally, the IDF build system does use modern CMake concepts, such as declaring libraries, declaring private and public properties of libraries, and using target link libraries as a glue between them. However, there are important differences with regards to how libraries are added to the build, and as a result, a plain CMake library typically cannot be used as an IDF component. And we need to wrap that CMake library into an IDF component in order for it to be used. There are some links to GitHub issues with discussions about incompatibilities between ESP-IDF build system and plain CMake that I'm going to leave here. And before we move on, I just want to say that we do recognize this as a problem, and in the future versions, IDF will move closer to plain CMake so that people who know how to write CMake-based projects will be very comfortable in ESP-IDF build system. Let's move on to part 2. Here we talk about building an application using the IDF build system. We start off with creating a project, and for that we can use the IDF-PI create project command. If you're using an IDE, then there is going to be usually a way to create a project from a template. And when you create a project, either using this command or using the IDE template, you will get something like this. Typically, there is a CMake list file in the project directory, and then there is the main subdirectory with the source file and another CMake list file. At the root of the project there is a project CMake list file, and the very basic version of it only defines the project and gives the name. In this case the name is just the app. Then there is another CMake list file which is inside the main subdirectory. Now the main subdirectory is a component. You can have more components in the application than main. This is just the default location where you often start putting your code. The main component CMake list file also looks pretty simple, and it only declares, in this case, the only source file that the application consists of. And in the template, the source file just has the empty app main function, which is the entry point of the application. Now we can build the project. When you run IDF by build, as I mentioned before, it will execute CMake. The CMake will generate the build script, and the build script is now being executed by a tool called Ninja. Finally, at the end of the process, we will get the compiled application in the build directory. So the build process is complete. We can take a look at the result. We see that two new files have been created. There is an SDK config file and there is a build directory. And inside the build directory, there are many files, but the important ones I listed here. There is a config subdirectory with the sdkconfig.h. If you have already written the application, you will know that the sdkconfig.h is where this C code can take compile time configurations from. There is a bootloader directory, the partition table, all those things get flashed onto the chip along with the application. The application binary that gets flashed, the application L file that can be used for various tools such as debugging, GDB step, core dump, and so on. The map file can be used to analyze the application size layout using some IDF commands like idf.pysize. Compile commands JSON is the so-called compilation database, and it often is used by IDEs to provide code navigation and automatic completion. Project description JSON contains project metadata. It's an ESP-IDF specific file, and it's a way for the build system to communicate information about the project to various command line tools and to IDEs. And finally, the two Flasher related files, they contain all the information needed to flash the project and are used by tools such as idf.pyflash. In addition to the build directory, there is also SDK config file, which stores compile time configuration of the project. The SDK config file can be modified either manually or using GUI tools or using command line interface such as menu config. And we can either consider it as a build artifact, so add it to git ignore, or we can track it in Git. I will explain the difference between those two approaches in a moment. Before we move on to talking more about extending our project and adding more features to the project, let's talk about the configuration system. The configuration system is designed to create the two files sdkconfig.h and sdkconfig.cmake, which provide a set of compile time configuration options which can be used in C code for sdkconfig.h and in CMake for sdkconfig.cmake. The source of the configuration is the file called sdkconfig, and at first when we compile the application until sdkconfig is created, the configuration system reads all the information about the configuration options from kconfig files. It gets the default values from sdkconfig.defaults file if it exists, or if it doesn't, from kconfig files, and generates the initial version of sdkconfig, and also generates the initial version of sdkconfig.h and sdkconfig.cmake. After you edit the sdkconfig file, either manually or using a tool such as menuconfig or a GUI configuration editor within the IDE, the sdkconfig file will be modified. And after the sdkconfig file is modified, there is a configuration regeneration process. So the output files will be regenerated based on the information in sdkconfig, so updated configuration, and again values in kconfig files and in sdkconfig defaults in case some value is missing from sdkconfig. Finally, the new sdkconfig.h and sdkconfig.cmake files will be created and used throughout the build process. You can also take the SDK config file and create SDK config defaults based on SDK config. This means that all the settings that are equal to their default values that are specified in kconfig files will not be included, but any setting that you have changed, that you set differently from the default value in kconfig file, will be added to SDK-config.defaults. If you use this approach, then you can put SDK-config.defaults file into your Git repository, and you can add SDK-config to gitignore, and you can then use this SDK-config.defaults file as the main source of truth for the configuration of your project. So to summarize, all components in the application can define compile time configuration options using kconfig files. The SDK-config file will be created based on the defaults in SDK-config.defaults and in kconfig files. The SDK-config.h and SDK-config.cmake will be generated based on SDK-config. And you have a choice of either tracking SDK-config or SDK-config.defaults in Git, and you can choose between the two options based on what you prefer. Keeping SDK-config in Git gives you more stability in the sense that updating the ESP-IDF version is guaranteed not to change the options automatically, but the other approach is to keep SDK-config.defaults in Git, and that has the advantage that you actually will receive the updated values in case ESP-IDF gets updated, and also SDK-config.defaults file is much easier to document and explain why you want a specific value of a given option. So it might be better for maintainability. Now, this was the brief introduction to the configuration system. Let's move back to our project, and it's time to take a look at the component CMake list file. Inside the component CMake list file, we see the IDF component register function, which in our example only added one source file and one include directory. The main things that you will be doing with the IDF component registry is IDF component register function is defining the list of source files, either using the srcs keyword or list of source directories using src-dirs keyword. You can define the list of include directories using include-dirs or priv-include-dirs keywords, and you can define dependency between components, and we will talk about the dependencies topic in a bit. There are also some additional parameters you can specify to IDF component register, such as for linker fragments, embedding files, and so on. I will not cover this in detail. This is covered in the documentation. In addition to using IDF component register inside your component CMake list file, you can use other common CMake functions. For example, if you want to work with lists, you want to work with files, or you want to generate something before compiling it, then you can implement those steps as you would in normal CMake. The common thing that you will be doing after creating the application is probably creating new source files and new header files. And in this case, in our template application, I have added a new source file appcommon.c. I have also moved both source files into the src directory, and have created an include directory where I have added a file appcommon.h. And after those changes, the component CMake list becomes like this. So the srcs now contains two sources, and the include directory, this is a private include directory. Again, I will explain the distinction between the two. The include directory is include. A few tips. First of all, if you have a choice, I would recommend using sources keyword rather than source dirs. Basically, it means that you list all the files explicitly. This gives you much more predictable behavior, and in case you add a source file but you forget to commit it into the project, then you will get the error, which will be when it means that something is wrong with setting the component requirements. And I will explain how to set the requirements correctly in a second. You can use double quotes, or you can skip your double quotes. The only case when you need double quotes is if the path to this source file or the name of the source file contains a space. Otherwise, double quotes are not necessary. I'm using them here in the example just because it makes better syntax highlighting. The next thing that you can do after adding your own source files is adding dependencies to external components. And this is done using a file called idfcomponent.yaml. It is a IDF component manager manifest file. The components are added to this file in the dependencies dictionary. I will not cover the syntax of this file too much in detail. Here is a link for the documentation of IDF component YAML. But in the most simple case, you just list the components that you want to add to your application and the versions of those components. When the build system runs, those components will be downloaded into a new directory called Managed Components. Managed Components is also a generated directory, so it's recommended to add it to gitignore and not modify the directory. The components will be downloaded inside this directory and added to the build. Additionally, there is going to be a file called dependencies.log, which will contain actual versions of all the dependencies, meaning that if you want to achieve reproducible builds, then it's recommended to keep this file around. You can also achieve reproducible builds by specifying exact versions of dependencies in the manifest file, but the log file gives you a better guarantee. Now let's return to the topic of configuration and see how we can add configuration options to our component. As we talked before, configuration options are defined in kconfig files or kconfig projbuild files. The difference is only where those configuration options appear in the configuration editor. If you add an option to kconfig file, it will appear under the component config part, and if you add the option to kconfig projbuild, then it will appear in the root menu of the configuration editor. Kconfig files have the same syntax as kconfig in other systems like Linux or Zephyr. I left a link to kconfig syntax reference here. And in kconfig file you can define options of different types, for example Boolean options or string options. The recommendation is to define things in kconfig that really need to be known at compile time, and avoid defining things that are more of factory settings or things that might change at runtime. For those things, it's better to have a runtime variable, for example, that can be set during the application execution, or if it is a factory setting, then you can store it inside NVS or some other file system. However, kconfig options can also be convenient for some simple configuration or setting some default values, so you can use them for those purposes as well. Now let's talk about what happens when the application has been developed for some time and it has now more and more functionality. So you might find having a lot of source files in your main component. This might be the point when you could consider splitting the main component and introducing additional components in your application. The reasons why you could split the main component and introduce additional components could be to simplify maintenance. For example, if you have more than one developer on your team, maybe different developers will be responsible for different components. The second reason could be to reuse those components between products. If you have multiple applications or you're building applications for multiple products, you may have some common parts of functionality that you will not keep in each single project, and in this case, moving this functionality into a separate component can let you reuse the code. And finally, sometimes creating separate components for different parts of your code forces you to think about responsibility of each source file, each header file, and create stronger and more clear interfaces between parts of the code. And that also helps with maintainability and avoids having really complex dependencies in your application. How to create a new component? We do this by creating a directory called components inside the application and adding a subdirectory there. The name of the subdirectory is going to be the name of your component. In this case, I've added the app-common subdirectory into the components directory of the application and moved the two files that I have created prior to this, app-common and .h and app-common.c. Now AppCommon is a component and it can be reused between different applications if I have some common functionality for all my apps. The structure of the component defined in components directory is the same as for the main component. You can have a CMake list file, you can have IDF component YAML file, you can have kconfig, and all the other things that we talked about, and also the things we will cover in the future. What's inside the new component? So we have CMake list file. Again, in this case, it only adds one source file and one include directory, so it's the same as we've seen before. I've added a sample piece of code both to the header file and the source file. It's just a simple function that initializes storage from application perspective, and in practice this function to initialize the storage just calls the NVS flash library to initialize it. Now if we put this all into our existing sample application and try to build it, then we will actually run into the following compilation error, that the nvs.h file hasn't been found, and we used nvs-flash.h over here. You might wonder why that is the case, because if we put the same exact code into the main component like we had previously, then everything will compile successfully. If you are using a recent version of ESP-IDF, you will receive additionally a hint after this error message, and the hint is going to tell you that the compilation failed because the source file in your AppCommon component included nvs-flash.h, but it didn't add nvs-flash.h into the requirements list, and the solution would be to add nvs-flash to prev-requires list when you're calling IDF component register in the CMake list file of AppCommon component. If we follow this hint and we modify the CMake list file of the component like this, basically just adding nvs-flash after the prev-requires keyword, then the build will succeed. This brings us to the topic of requirements, why they are needed and what they actually do for the build system. The prev-requires list that we pass to IDF component register, this one, is a set of components that we can use in the source files of our current component. If you're familiar with CMake, then it is equivalent to calling target link libraries, where the first ellipsis is your library and the second ellipsis is the target library, basically the library from which you want to use the header files or the functions. Additionally, there is also a requires list, and it's different in that if you need to use a header file of another component in the public header file of your own component, then instead of prev-requires, you have to add that dependency into the requires list. And what this does, in addition to what prev-requires does, is it propagates the dependency on the target component also to the components that use your own component. So it becomes a transitive dependency. So here is a summary. You use prev-requires same way as you would use CMake keyword private, and the dependency is added, in this case, only to the sources of your component. If you use this IDF component register keyword requires, then it's equivalent to using CMake keyword public, and in this case the dependency is added not only to the source of your component, but also to the dependent components. Here is an example that is related to our previous situation, where we had the main component with main.c, AppCommon component with AppCommon.h and AppCommon.c, and two other components, ESP-Common and nvs-flash. The requirement that we were missing was this one, number 1, and AppCommon.c uses a function defined in nvs-flash.h inside nvs-flash component, and therefore AppCommon.c needs to have nvs-flash in its prev-requires list. The second requirement from main.c to AppCommon.h, so if main.c calls the function defined in AppCommon.h, it's very similar, because main.c calls a function defined in AppCommon.h. The CMake list file of the main component needs to have prev-requires AppCommon to declare this dependency. There is actually a third dependency in here that we haven't talked about before, because appcommon.h is a public header file of appcommon component, meaning that it can be used by other components, like main in this case. Because appcommon.h uses another header file, esp-error.h from esp-common, appcommon would need to have esp-common on its public requirements list. However, as you noticed, in practice we didn't have to add this, and I will explain why in a second. So first, there are two things to note. When we had the appcommon header file and appcommon source file inside the main component, we actually didn't need to add the requirement at all, and the compilation succeeded. Why is that? Well, the main component is special in ESP-IDF build system, and this is the behavior that has been carried over from the previous GNU Make build system. In GNU Make, there was no concept of requirements between components, so every component in the build could use every other component in the build. However, when we migrated to CMake, we wanted to introduce those requirements, but to simplify migration, we kept the behavior that the code in main component can still use header files from every other component in the build. And this works until you start specifying dependencies for the main component. So, if the main component doesn't specify any dependencies, then implicitly it is made dependent on all the components in the build. As soon as you add requires or pre-requires to your main component, then you have to start specifying all the dependencies. Now, I don't recommend relying on this behavior. It's convenient when just combining features from different examples really quickly without having to worry about dependencies. But if you're developing a real application, I would recommend thinking about the dependencies, which components you use, and adding those components to the requirement list. You can read more about this in this documentation link. The second caveat here is related to the reason why we don't actually have to add esp-common to the requires list of appcommon. And this is related to common requirements. There are certain components that, for reasons of backward compatibility and also for convenience, are automatically added as dependencies to every other component in the build. It means that if you're using a header file, for example, from heap component or log component or esp-common component, like in the previous case, then you don't have to declare that dependency, and IDF build system will automatically add that dependency to every component. This list of common requirements will most likely shrink in the future. Primarily, this should happen in major releases of ESP-IDF. So in ESP-IDF 6.0, it is likely that a few components will be removed from the list of common requirements, and you will have to declare dependencies on them explicitly. So those two caveats explain why first of all, why we didn't have to declare dependencies when appcommon files have been in the main component, and second, why we don't have to declare dependency on esp-common from appcommon. There are a couple of things that I also want to point out with regards to limitations associated with the requirement system. And the first one is that requirements between components cannot depend on kconfig options. For example, this snippet will not work. You might expect that we can check if a certain configuration option is set, and we can add the component dependency into the requirements list, but this will actually not work. And what will work is adding the dependency late. So for example, we can call IDF component register without specifying that additional dependency, in this case on ESP-PS-RAM, but after IDF component register we can call a CMake if command to check if that configuration option is set, and if it is set, then we can add the requirement on ESP-PS-RAM later. And the reason for this is the process of CMake list file evaluation in ESP-IDF, where actually every component CMake list file is evaluated twice. The first time every CMake list file is evaluated to find the dependencies between components, to scan for requirements, and the second time it is actually added to the build using CMake add subdirectory command. For that reason, you cannot call any CMake commands which don't work in script mode until you call IDF component register. So after IDF component register, all CMake commands, including those that only work in project mode, not only script mode, will work, but IDF component register has to be relatively early in your component CMake list file. Now, this is one of the limitations that I mentioned before when talking about compatibility between plain CMake libraries and IDF components. So this is something that you need to keep in mind, especially if you are porting an existing CMake library into ESP-IDF. Sometimes you will have to wrap that CMake library into an IDF component to resolve this problem. What do component requirements actually give us? The main thing is that component requirements allow us to compile only what is actually needed in your application. If you remember, when I built the sample project, it compiled nearly 800 files. And this is because all the source files in ESP-IDF have been compiled. And the reason for this is because the implicit behavior of main component, where it depends on everything by default. As soon as we start specifying requirements, meaning that we specify the requires and pre-requires in component CMake list files, and we also set the components variable in the project to some smaller set of components, we can trim the build, meaning that we can only add the components that are in the components variable, plus all the components that those components depend on. There are some docs that explain this further. I left a link here. Here's what it's going to look like in practice. In our project, we will add set components main before calling the project function. And then in the CMake list file, in this case the main CMake list file, we also specify the requirement on app common. Now, if we build the project after this, then the build will take much less time, and also fewer components will be built. There is another caveat here to keep in mind, that certain features require the respective components to be included in the build. And if you follow this approach, then you might not actually have those components in the build by default. For example, if you want to have PSRAM support, you need to make sure that ESP PSRAM component is included. If you want to use GDB stub, you need to make sure that ESP GDB stub is included. If you want to use core dump, you need to make sure that ESP core dump is included. And you can include them either by adding them to this list of components, or by adding them as a dependency into one of the CMake list file of your components. Now that concludes the second part of the presentation. We have walked through the main things that you need to know when creating the application, and now I will give you a set of recipes for different things that you might want to do within the build system. One of the common things you may want to do is to do things conditionally in the build system. For example, conditionally add files, meaning that you check if a certain configuration option is set and you only compile a certain file if that is true. The syntax is pretty simple. As I mentioned before, we cannot use commands that cannot be used in CMake script mode until we call IDF component register. But all the basic commands such as set, if, list, and so on, they can be used in script mode. So we can perform some logic based on configuration options and create a list of source files and then pass them to IDF component register. Another approach might be more familiar to CMake developers who have already used target sources command. In this case, we register the component providing only the common source files, and then depending on whether a certain configuration option is set, we're going to call target sources to add additional source file to the component. In IDF component CMake list file, this component lib is a predefined variable that contains the name of the library target of the current component, and you can use this variable wherever you're calling CMake target functions. For example, target sources, target include directories, target link libraries. Another common task is to add compiler flags or compile definitions. If we want to add compile flags, we have to decide for what set of source files we want to add that flag. If we want to add compiler flag for the whole component, we can use target compile options CMake command, and in this case we again specify component lib as the target and the flag that we want to add. If we use private, then the flag will only be added to the source files of the current component, If you use public, then the flag will be also added to this when compiling the source files of all the components which depend on this current component. You can check the CMake documentation reference about the target commands, not only include the ones about target compile options. If we want to apply the flags to a specific source file, and this is commonly done if we have, let's say, some upstream sources that have some compilation warnings, we want to exclude those warnings from the build, then this can be done using set source files properties command. And in this case, we use the compile options property and specify the flags that we want to add. Sometimes it is necessary to set the flags for the whole project, like for instance in the case when we want to enable undefined behavior sanitizer. If we want to enable a certain compilation flag for the entire project, then there is a IDF specific command called IDF build set property, and the name of the property is the same as CMake name of the property, so in this case compile options. The append keyword means that we are not overwriting the list of flags that have been previously added, and we are adding a new flag. You can find more about the IDF build properties, not only about the compile options, over here. In addition to adding compiler flags, we can add other compilation definitions. For example, we can add preprocessor macros. For this, we could use target compile definitions if we're adding those macros for the component, or we can use compile definition CMake property together with set source file properties if we are doing just for a single source file, or we can use IDF build property with the same name with IDF build set property if we're doing this for the entire build. And this table shows similar functions that you can use for other things, for example, for C specific compiler flags, C++ specific compiler flags, and for the linker options. Now for target compile options, the distinction here is that you will have to use generator expressions that depend on the language. I'm not covering this here. You can find the recipe for using target compile options with generator expressions in CMake documentation. Another common thing that sometimes we have to do is to add external libraries, meaning libraries that are not yet ESP-IDF components. And there are two cases here that I want to cover. First is when we add a CMake library that supports being added via add subdirectory command. Many CMake libraries can be added to your project using add subdirectory. And in this case, typically wrapping such a library into an IDF component is really easy. You put the library into a subdirectory of your component, either using a Git submodule or just downloading the source code. You can also download the source code during the build process. You register the component as an empty component that doesn't contain anything, and then you add that downloaded library using add subdirectory command. Sometimes you have to specify additional options. These will depend on the specific library that you're adding. In this example, I'm adding the FMT library, and FMT library has a specific option to disable the installation features. And finally, to actually attach that library to our component, I use target link libraries, linking to the component library, meaning the library of this component declared with IDF component register, the target library, the one that has been added using this add subdirectory command. For many CMake libraries, the approach will be very similar. There are other cases where it becomes a bit more complex. For example, if the library doesn't use CMake build system, or if the library doesn't support being added using add subdirectory. In this case, you typically have to use external project add command to add the external build step to your CMake application. I will not cover all the details, but there are 3 examples that you can refer to linked here, and they show how to integrate libraries, different kinds of libraries into an ESP-IDF component. Embedding data and creating file systems is another thing that IDF build system helps you with. To simply add a text file or a binary file into your application so that it can later be used in C code, you can use embed txt files or embed files keywords in IDF component register command. You can also create file systems automatically during the build process. For example, for FAT file system or for littleFS file systems, there is a very similar syntax where you call a command fatfs create SPI flash image or littleFS create partition image, specifying the name of the target partition where you want to add the file, the directory which contains your source files, and a keyword saying that you want to flash those files during IDF by flash. And for NVS, there is another function that has been added to IDF somewhat recently that takes a CSV file containing all the key value pairs and a name of the NVS partition, and also that generated NVS binary can be flashed together with the application, making it pretty convenient. Doing work before or after the build is commonly necessary when we need to generate the code that is later compiled, or when we have to post-process the binaries in a certain way. Generating intermediate files and using them in later stages of the build process can be done using CMake add custom command function and add custom target. You can use add dependencies to add the dependency from your component, making sure that those steps, those custom steps, are done before building your component. And then later inside your component you can use the generated file somehow. In this example, I'm generating a certain binary based on a certain source file using a custom script, and later that binary gets compiled into the application using the target add binary data. If we want to perform post-build steps, then there is an add custom command with the post-build keyword. And this command will run whenever a certain target is built as an additional step. This can be done, for instance, when to create archives of generated binaries or to upload the binaries somewhere. And then another type is a custom command that can be run manually. And in this case, we can define those commands using add custom target. This command will not be by default executed when the build process is running, but you can invoke this command manually either as a CMake target or using IDF-PY. IDF-PY supports calling CMake targets just like this, and sometimes it can be useful to wrap a certain script. For example, if you want the users of your application or your component to be able to perform a certain step, you can wrap this step into an custom CMake target, and it will be executable through IDF.py. A certain number of things in the IDF build system can be customized. For example, the name of the main component can be customized using the extra component dirs variable. There is a documentation link over here. The name of SDK config file and the place where the SDK config file is located can also be customized. This is convenient if you're treating SDK config file as a build artifact and you're not tracking it in Git. You can move it, for example, to your build directory. And the build directory itself can also be customized using the -b option of idf.py. It mirrors the -b option of CMake. So you can specify in which directory you are actually going to do the build. Combined, these two customization options give us a way to have multiple build configurations side by side in ESP-IDF. And the way to do this is to create multiple SDK config.defaults files. Now, I'm showing here an example where I have created SDK config defaults files for two different products. The differences between those products will somehow be encoded in the different settings, different kconfig option values. Those can be either standard IDF kconfig options or custom kconfig options that are specific to your product that you can define in kconfig files. For each product, we will have one build directory, build prod1 and build prod2. SDK config files for each configuration will live inside the build directories. And for this layout, you can follow the link below for an example. Now, to build one of the configurations, we can execute an idf-py command specifying the build directory and specifying the list of SDK config defaults. So first the default that is part of the application, and then the second default is specific to the product, and we specify where the SDK config file is located, and then the actual commands, in this case build/monitor. Now, in order to not have to repeat all those parameters every single time, we can create configuration files or argument files. The argument file will just contain all those arguments specific to this product. We can save this argument, for example, in the prod subdirectory, let's say prod/1. And when we call ESP-IDF, we can mention this file using this @ sign, and then the name of the file containing the argument list, in this case prod/1. This is exactly the same as just listing all the arguments contained in this file on the command line, just shorter. So now to build different configurations of different products, you can run idf-py @ sign the name of your product and then build/monitor. And the final thing that I want to touch on is how to share components between different projects. We talked before that at some point you will find that certain parts of your applications can be reused in other applications or for other products. And if you can no longer support multiple products just with different configurations of the same app, you may want to have multiple products inside your project. Here is an example layout of a project that you could adopt. In this case, I have multiple IDF applications, one for each product inside the project directory. And there are certain components which will be common between the applications that are located in the common components directory. There are a couple ways to add common components to those product applications. One is to specify extra component dirs variable. In this case, in project CMake-list file, you can add the common components into extra component dirs, and those components will be built within your project. You can either add the whole common components directory or add specific components that you need. The second approach is the one that we do recommend right now over the extra component dirs, and it is to add those dependencies to IDF component YAML file, same way as you would add dependencies on third-party components or other components published in the IDF component registry. In this case, we just use the name of the component and the path where it's located, and this can be a relative path. This also makes it easier to later move those components, those common components, either to a Git repository, and then you can again bring them back in using IDF component YAML, changing the path keyword to Git, or using submodules if you prefer. So these are the couple ways you can structure your projects as they grow and support more products and contain more components. With that, that's the end of my presentation, and if you have any questions, I will try to answer them.
Hello everyone, and welcome back to the second day of DevCon24. My name is Pedro Minatel, Developer Relations Manager here at Espressif. And for this first Q&A, I would like to invite Ivan to join us here in the Q&A chat, or the Q&A room. Hi Ivan, how are you today?
Hi Pedro, I'm good. How are you?
Yeah, I'm good, thank you. So first of all, thank you very much for your talk. And I see a couple of questions here, and maybe we ready to go to the first one, right?
Sure, let's go.
Okay, so first question is there any way to speed up rebuilds whenever the SDK config changes? It rebuilds pretty much everything every time anything changes. And we have another related question, which is recompiling a project is rather slow because apparently all the ESP-IDF components are recompiled, even if they are not actually used. For example, like Wi-Fi. Any hints to speed up the build?
All right, so I'm going to answer first the second question. So that one is addressed in the talk. I think was a comment there already. Basically, this is a very common thing that people meet because this is the default behavior of most IDF example projects. That is to say that we take all the components inside IDF and also inside your project, and we compile all of them by default. But this behavior can be overridden, and the key to do this is what has been shown in the talk. we can add the set components main in the project at the project level, and we can specify all the requirements between components. So this way, the build system will know that which components are needed and not needed, so they will not be built or rebuilt at all. The second part, or rather the first question about SDK config, that one is it's a problem indeed that in ESP-IDF this SDK-config.h file is included into a lot of source files. So whenever you change something in the configuration, even if it's an option unrelated to the specific source file, the source file still gets recompiled. Now, there is a thing you can do right now, and that is to make sure that you're using Ccache. To use Ccache with ESP-IDF, you just need to have it installed. You don't need to do anything else. ESP-IDF build system will automatically detect that you have Ccache installed, and in the build log, you will see a line using Ccache for fast rebuilds. Now, what Ccache is going to do, it will first take basically, Ccache is a compiler cache, and it can help reuse object files that have already been compiled. So what Ccache is going to do is it's going to check, is the source file and all the header files that it used and all the compilation options the same as were used in the previous build? And if the answer is yes, then it's just going to take the existing object file without ever calling the compiler, and that's going to be pretty fast. The next thing it's going to do is, if it notices that some header files, for example, have changed, it's going to run preprocessor. Now, running preprocessor is oftentimes faster than running the compiler. So if Ccache sees that after running the preprocessor, the preprocessed source file is the same as it was last time, it's not going to call the compiler again, and it's going to reuse the object file. So what's going to happen is that if you change a configuration option, but this configuration option only affects a small number of source files, in the build log, you will still see that a lot of files are recompiled, but actually, due to Ccache, only the preprocessor will run, and then the Ccache will take the already compiled object files. So it's going to be not as fast as not compiling them at all, but it's going to be much faster than if you don't use Ccache. Longer term, we are considering whether we can split SDK config file into multiple files. So right now you have a global SDK config.h for entire ESP-IDF. All the components are present there. But in the future, we might have configuration files for each component. And then we can optimize this, because if, let's say, a certain component only needs configurations, or let's say its own configurations, which is often the case, then it only includes the configuration file for that specific component, and that configuration file is not going to change when unrelated options are modified. Now, this approach also has its own downsides, which is why it's not implemented still in ESP-IDF, but this is something that we are considering doing in the next versions, and then the situation will be much improved in terms of rebuilds.
All right. So thank you so much for this detailed information, and I'm pretty sure that it will be very useful for many developers. The second question is also related to components. Is there a way to create a component list to download the most common components online?
Yes. This is something that you can do. You can create a component which contains no source code. And the only thing that the component will contain is, let's say, a CMake list file, which we'll call just IDF component register without registering any source files, and IDF component YAML file, which will specify the components that you need, those common components, as dependencies. So this file will basically tell the build system that the component requires those other common components that you want to use. So you can create, for example, my common components component that will have dependencies on all those other components that you frequently use, and then you can just add that single common component to your project as a dependency. So this way, all the other components will be pulled in. There is a trick there. You have to think about how you specify versions of the dependencies, because thinking about setting the version of your dependency is very important for handling the possible changes in those components, which might get updated in the future. So you still have to think about that in maybe more detail, depending on how we want to use those components, but that's definitely an option.
Perfect. Thank you. So we have one more question here, still related to components. is there a way to add private GitHub components to the ESP-IDF component manifest file for automated CI/CD with ESP-IDF CI?
Yeah, it is possible. I actually have I think I have a slide about that in my last year's talk. I can leave the link to the slides in the chat. The way you do this is in IDF component YAML file, you can specify dependencies on Git repositories. And you place your private component into a Git repository or into an absolute path if you prefer to not use Git repositories. And then this component will also be included in the build. So it's possible in the same project to mix the components that come from your project, from the component registry, so public registry, from absolute paths or relative paths on your disk, and also from Git repositories.
All right, thank you again. So I see that you already shared the link for your slides. Thank you very much. So it's in the chat for anyone who wants to see or see later the presentation. Eva, I'd like to thank you for the talk and for being here answering the questions.
Thank you, Pedro.
And now back to the studio.
Thank you, Ivan, for an amazing talk. Sudeep, have you ever visited Hungary?
As a matter of fact, I have, Annie, but I think I have so far visited only Budapest.
Only Budapest? Well, I would recommend you to go to the Balaton area because it's absolutely amazing and you will see fields of lavender, which is my personal favorite.
I will make a note of that. Thank you so much, Annie.
You are very welcome. And also, this actually brings us to our next speaker.
Absolutely. We are thrilled to have Gábor Kisvámosi, CEO of LVGL, joining us all the way from Hungary. Gábor will show us the power of the new ESP32P4 and bring it to life with the LVGL library, with its stunning UIs, complex gradients, and animations.
So people, are you ready for some serious eye candy? Let's dive into the world of LVGL with Gábor.
Welcome everyone. My name is Gábor Kisvámosi and I'm the leader of LVGL and also the CEO of LVGL LLC. In my presentation, I will talk about how you can use great user interfaces with LVGL on the new ESP32P4. I will start with introducing LVGL in general. After that, I will tell you how you can use or add LVGL into the ESP32 ecosystem. After that, we will check out some use cases about some great LVGL features that you can utilize with ESP32P4. Finally, I will talk about our future plans, and of course, I will be happy to answer your questions too. So let's start with what LVGL is. LVGL stands for Light and Versatile Graphics Library. So it's a graphics library which helps you to create impressive user interfaces even for resource-constrained embedded devices. It's a full-featured library. It contains more than 30 built-in widgets like keyboards, charts, sliders, buttons, labels, text areas, and many more. What you see on an Android or iOS application usually can be realized with LVGL as well. LVGL comes with a powerful style and layout system too. These are inspired by CSS, the styling scheme of the web pages. So the same technologies which make the web so powerful are available on LVGL as well. It includes more than 100 style properties and modern layouts to automatically and easily arrange the size and the position of the widgets. It also comes with an advanced typography system supporting many languages, including the Asian languages, the Arabic languages with right to left and left to right writing direction support, and of course the Latin-like languages too. We will check out some examples for these later in the presentation. LVGL is free and open source. The whole source code is distributed under an MIT license and fully available on GitHub. In the practice, the MIT license means that you can just download LVGL, add it to your project, and use it without any issues, even for commercial projects. The only thing that you need to do is adding a note in your documentation, user guide, or README to tell people that you have used LVGL in your project, and that's it. I'm very proud to say that LVGL is the most popular free and open source graphics library at this moment. It's downloaded every minute from GitHub, and it's already supported by the leading vendors of this industry. Of course, it's being supported by Espressif as well. LVGL is a platform-independent solution. You can use it for any microcontroller, microprocessor, any real-time or normal operating system, and you can drive any kind of displays with it. It includes OLED, e-paper, grayscale, TFT displays, or even monitors. And finally, I'd like to tell that we are doing some services. We are doing UI design, UI implementation, and you can consult us if you have any questions during the UI development. We also have a broad global partner network. So if we don't have capacity to take your project right now, I'm sure that we can find a great company for you who can help. On this slide, you can see some interesting stats about LVGL. The first thing that you can see here is how many contributors we already have. It's more than 400. It means that more than 400 people helped to make LVGL better by fixing issues, reporting bugs, or implementing smaller or larger features. We also have more than 15,000 stars and more than 3,000 forks. As I already mentioned, according to the statistics on GitHub, we can see that LVGL is being downloaded in every minute. However, it doesn't count other sources like Platform.io or Arduino libraries, or even ESP registry. If I consider all these sources, it's quite reasonable to say that someone downloads LVGL in every 10 seconds, which is, mind-blowing for me, to be honest. I'd like to also show you our new website. It was published in July, and basically all I have said so far in the presentation is available here as well. On the homepage, you can see some basic UIs and related code. So you can see how you can create an arc, for example, set the size, the position, or create a label on it. All these basic examples are available right here. Here you can see our partners. These are some more complex demos. The supported frameworks. But the other page that I like to show you is the features page, because here I can showcase some great LVGL features. This is our basic widget demo, where you can just try out how the basic widgets look like. All these demos are written in C, but they are compiled to an HTML page, so that HTML page can be shown on any websites. On some projects that we are working on, we usually compile the actual UIs to web pages, so the designer team or the managers can easily take a look and share their comments. Here you can see some rendering features. On this UI, there are no images at all, or these are rendered by LVGL, including these gradients, these shadows, these arcs, and all these shapes here. This is about the styles. This is a basic LVGL slider, and it shows you in how many ways you can change its appearance. All these are rendered by LVGL's rendering engine, and only a few images are used for these stripes or this knob, but all the other stuff are created and adjusted by just changing some style properties. This one is about the layouts. Here you can try out LVGL's flex layout in action. As you can see, these boxes are just placed next to each other. However, if you enable the row wrap mode, these are wrapped automatically. You can also arrange these into a column. And yeah, you can play with it if you like. This is the demo that you have already seen. And here we like to showcase the multi-language support of LVGL and how you can mix various fonts. Here we have a Chinese text, an Arabic text, an Indian text with some inline emojis. This is about transformations. In the latest version of LVGL, you can you can apply any transformations on the widgets. It doesn't have to be an image. It's really a working widget, not just a simple image. LVGL takes a snapshot in this case and applies a transformation as it were an image. But all these are working in runtime. Here the scrolling features. I don't want to go into the details, but as you can see, there are some very nice chained scrolling, this elastic scrolling feature, and many more that you can try out by adjusting these switches here. And that's it. Let's get back to the presentation. So let's see how we can use LVGL with the ESP32 ecosystem and how can we get started. I think the best source of LVGL in order to add it to the ESP-IDF for the ESP projects is the ESP registry. LVGL is distributed there as well. Here I sorted the components by total downloads, and you can see that LVGL is the third. So it's the third most downloaded repository in ESP registry and the first source-party library. So if you would like to add the LVGL to your ESP project, you can use the usual IDF commands to do so. If you are using Arduino or Platform.io, you can also add LVGL very easily because it's being distributed as an Arduino library and a Platform.io library as well. Besides that, we are maintaining an Espressif-related documentation in LVGL's documentation where we list all the related commands, some optimization opportunities, and all the other nodes that might help you to get started. Besides that, with the help of the great Espressif engineers, we have created some ready-to-use projects in LVGL's GitHub organization for some ESP and M5 stack development boards. You can just go to those projects in github.com/LVGL. You can clone them and find all the related get started informations in the README. They are optimized for performance, and the target was the simplicity. So these can be considered as a good getting started projects that you can just easily extend later on. And finally, the engineers of Espressif maintains and creates the ESP-BSP repository as well, where you can find several LVGL-related demos. Okay, now we have arrived to the most important and most interesting part of the presentation. We will see some LVGL features and check them out to see how you can make your UI better on ESP32P4. But let me tell you a few words about P4 first. As you probably know, it's a dual-core 400 megahertz chip, which is really amazing because 400 megahertz is already enough even for really complex and good-looking UI effects as well. It also has 768 kilobytes of on-chip SRAM, which can be enough for a double buffered 480 by 272 resolution display. So you don't have to place the frame buffers into the slower PSRAM, but for mid-size displays, you can use a faster internal SRAM. According to our experience and measurements, the maximum reasonable resolution for ESP32S3 was 800 by 480. It was sometimes a little bit lucky, but with careful design, you can create decent UIs on this resolution. However, for P4, even way larger, like HD screens, were working very well. So I think it's a huge step forward. So the first set of features that I like to show you is transformations and masks. You have already seen the transformations on our website, how they work and what you can do with those. But in this video, you will see them in the action and also the masks. But let's see the video and I will tell more about these after that. So these labels on the left-hand side are normal label widgets. These are not just images, meaning they are dynamic. You can change them at any time. And what we have done is made LVGL to transform them a little bit and also scale them as the ARC approaches them. Regarding the mask, these numbers here are maxed a little bit. If you take a closer look, you can see that the upper and the lower part of these numbers are faded a little bit. To do so, we have created an image, which is just an 8-bit image. The middle is white and the ends are getting blacker. And yeah, in LVGL version 9, the later version, you can add this mask to any widget and it will be, just mask out the black parts accordingly. Here we have created an image for the mask, but it could be generated in runtime as well. In the latest versions, you can render anything that LVGL can render in L8, so lightness 8-bit format as well, which can be used for the mask later. So in summary, you can transform any widgets as an image, not only images. You can generate masks at runtime. These masks can be labels or gradients or any shapes, and you can apply them on any widgets. I mean the masks. Oops. The other two features that I like to show are the Lottie animations and the multi-language support. If you are still new to the Lottie animations, these are like SVG images, but animated. They can be considered as a better version of the GIF animations because GIF was not really scalable because it was like pixel-based, not vector, and GIF had only 256 colors, while Lottie has ARGB 8888 colors, so it utilizes the whole RGB spectrum with 8 bits per channel, and also vector-based, so you can render the Lottie animations any size. Okay, let's see it in action. You will see it here. So yeah, this nice cogwheel animation is stored as a Lottie description and being rendered on a canvas. This canvas is basically just a buffer that can be provided externally by the user to the Lottie widget, meaning you can control where this buffer is located. It can be placed in internal RAM, PS RAM, or any other places that you like to control the memory usage in a bit more conscious way. Okay, here I have just selected the Chinese language, so the whole UI is translated to Chinese now. It can be possible, it can happen in an easy, simple way because LVGL supports the whole UTF-8 encoding, and you can type any UTF-8 encoded string and LVGL will be able to process it. We also have an internationalization or multi-language support tool, which can extract the strings to translate from the source code, place them in YAM files. In those YAM files, you can add the related translations and compile a C file from those translations. And of course, that C file can be added to your project, and LVGL can get the translations from that C file. It supports all the fallbacks. So for example, if there is no Chinese translation for a word, it will use the English version. If there is no English version either, it will use a tag, which was used in the code. One more interesting thing is if you have a Chinese UI, you might have like thousands of symbols or characters on your UI, and it's not really reasonable to convert a Chinese font with 3 or 5 different sizes and thousands of characters because it would consume like megabytes of flash. Instead, you can use LVGL's built-in TTF render libraries to open a TTF file and render only the required characters. It can also cache the characters for you, so the performance will be great as well. Actually, it's quite similar with the Lottie animation. It uses a built-in but third-party library in LVGL. In order to use Lottie animations, you just need to enable the Lottie support in menu config, and LVGL will compile everything automatically for you. There is one more translation that I like to show. This is the Arabic translation. As you can see here, not only the text are right to left written, but in Arabic languages, all the UIs are arranged from right to left. For example, the sliders are growing from right to left. The off state of the switches are on the right. And basically, everything is just flowing from right to left. And this is working in LVGL automatically. For example, this line was created by a flex layout, placing these items next to each other. However, when it detects that now we are in a right to left context, it will swap the directions automatically. The sliders and the switches can also detect the right to left or left to right context and change their behavior rendering accordingly. Okay, here I have listed some other features which are added in the latest version of LVGL, version 9. The first one is parallel rendering. This LVGL version 9 can utilize multiple CPU cores during rendering. Of course, the possible performance boost that you can achieve depends on the arrangement of the UI, how many things can be rendered in parallel, but according to our measurements, we can see that if you utilize both cores for rendering, you can experience like 30% boost. We have also added assembly accelerations to the rendering, so the most performance critical parts are written in assembly to make sure that you can make the most out of the given architecture. You can just enable these in LVGL's configuration file, and they will be added automatically. We also have a platform-independent profiler. In the practice, it means that we have already added some special tags to the performance-critical functions, and when the execution reaches those tags, they will add a string with a timestamp to a buffer, and when those functions exits, another tag or other string will be added to a buffer. So a lot of strings like this will be buffered, and when the buffer is full, it will be flashed via a serial port or something like that. And in the end, you will have a profiler log with a lot of function entries, function exits, and related timestamps. It's a little bit hard to digest in this form. However, there's a website which visualizes all this for you. You can see in which functions were executed, and you can see the whole stack actually, like this function was running for 1 millisecond, another function was called from there at this time, and it was running for 200 microseconds, and so on. It already helped a lot to us to debug performance issues and even very complicated scenarios. And yeah, it's a platform-independent profiler, meaning that you can use it on any platform, but in your application code as well. You can just use a few macros to add those tags into your functions, and you can monitor the performance. And finally, I'd like to tell you a few words about the observers. They can help us to realize data binding. In the practice, it means that you can create so-called subjects. These subjects are just storing values like an integer value, a pointer, or a string, or something like that. And various parts of the UI in the application can subscribe to these subjects. For example, you can create a subject for the user count, and a label in your UI can subscribe to the user count subject. This way, when the user count changes, the label will be notified and it can update its text accordingly. There are some built-in functions to make this process smooth and simple, but the great thing is that all these are dynamic. So if you create a label, you can just subscribe to the subject, it will read the current value and set the initial text accordingly. If you just delete the label, it will unsubscribe automatically. So it supports very well the dynamic widget creation and deletion. In the practice, it really helps a lot with dynamic UIs and to keep things simple, because these subjects can be considered as a single source of truth. You can just set the values there, and everything can read the current value from there. They can they can be also considered as the API of your UI. For example, this user count subject that I have just mentioned can be the value in it can be set by the application. So you don't have to create like large API functions to set the user count. You just need to document what subjects you have, and the application can set or read the current value from there. And the UI and the other parts of the application will be notified accordingly. Okay, that's it about P4 and LVGL version 9. Let me tell you a few words about our future plans, because quite exciting things are happening right now. In July, we have started to work on LVGL's official UI editor. It will be a developer-centric, declarative UI editor. By developer-centric, I mean that our goal is not to create a designer tool where anyone can put together fancy UIs, but instead we would like to help the developers to re-implement the UIs which were created by a designer. Of course, we will create a lot of ready-to-use components and demos that can be reused by people, but the main goal is to help the process of re-implementing the designs. We have found that in most of the projects that we were working on and we have seen, the designers are using Figma. So our goal is to make it as simple as possible to re-implement the Figma designs in our UI editor. If you would like to design a UI, we recommend using Figma. Design the UI there, because it's a very professional tool developed by many experts and used by large companies. We won't be able to create a better designer tool, but we can create a tool for you which helps you to implement and maintain your UI. Actually, this editor will consist of 3 parts. First, the editor itself, where you can create the UI in a declarative way. It means that you can describe the hierarchy of your UI like an HTML file in XML, and there will be a preview which shows you how it looks like. You can manipulate the widgets, all the properties, and finally export C files. As it's a developer-centric tool, it's a very high priority for us to make the generated code easy to use and easy to extend. It's not okay to have a large, bulky generated code that you cannot really touch. It can be very modular and integrated smoothly with the code that you add as a developer. As I mentioned, the second part should be a Figma importer, which helps you to move the Figma design to the editor. And finally, the third part that I haven't mentioned yet is an online preview. So once you have created some components in your editor, you will be able to push these or compile these to a website, just like we have compiled our demos to HTML files and show them on our website. You will be able to compile your components, every single component, into a small web page, and we will display them in an organized way where the designers or the other parts of your team can preview them online without installing any SDK or developer-related tools. Once we will have all the components and all the UI assets there, we can also run a tester. We can just compare how your components look like, and if there is some difference, we can detect some regressions and notify you that, hey, some components are not okay, you should take a look and fix them. So yeah, that's our plan about LVGL's UI editor. We are planning to release it in next year, summer, but until that we will publish some beta versions so that you can test it and give us feedback. We would be very happy to hear how you like it and hear any improvement proposals. But yeah, besides the UI editor, we are working on a project creator as well. It's a related tool. It's like we will release it before the editor to have like a hub where all the development boards that we maintain in LVGL's GitHub organization can be created as a ready-to-use project. you can just launch this tool as a VS Code extension, Eclipse plugin, or a standalone application. You can select the vendor, select the development board, also change some configurations, click a button, and the project will be created for you. It's very helpful for us because this way we can verify that the basics of our editor are working well. Like it's really running as a VS Code extension, Eclipse, standalone application, and hopefully on web as well. And it will also help you to create LVGL projects easily with some tweaking on the configuration. Later, we will extend this project creator to create editor projects, of course. So it will be like, if you would like to create a new project, launch the project creator, select the board, and after that, launch the editor and export the UI into the board that you have created. So that's it. We are working on the UI editor and the project creator right now. And yeah, we will share some news about these later. And thank you for watching. I would be happy to hear your questions.
Hello and welcome back to another Q&A. For this Q&A, I would like to invite Gabor. Hi, Gabor. How are you today?
Hi, all good. Very excited about the Q&A section.
Yeah, it's been like really nice. This second day is full of useful content and information. So first of all, thank you for your talk and for being here. And then we can move to the first question.
Yeah, my pleasure. Thank you.
All right. So first question is, can LVGL be used in CPP, or it's just going to stay in C code only?
Yeah, it's a great question. So we develop LVGL in C for the highest level of flexibility. However, we take care of making sure that LVGL is compatible with C++ and can be compiled with any mainstream C++ compiler as well. So even if you have a C++ compiler and a C++ based project, like you have if you are developing any Espressif related projects, you can use LVGL for sure. But if your question is more about if you can create your UI in a C++-ish object-oriented way, the current answer is no, because we don't have a C++ binding for LVGL. It's on our roadmap, and we already have a repository for that. There are some community, let's say C++ binding for LVGL, but it's not official and not mature at this moment. So it's on the roadmap to create something like button 1.set position, these kind of things, but it's not quite there yet. You can use a C API while it's being implemented.
Okay, I see. Thank you so much. The second question here is, do you have any example to run parallel rendering in the ESP32 S3 or P4?
Yeah, so one of the biggest improvements in LVGL version 9 was that now we are supporting parallel rendering with multiple CPU cores, for example. And there is no dedicated example because it's so simple to enable that it doesn't really require any extra example. You just need to change one line in menu config, which tells LVGL to create one more rendering thread. And if you have two CPU cores, then you will have two rendering threads running on two cores, so they will run in parallel. However, there is a catch. The effectiveness of this multi-core rendering pipeline depends on how many independent areas are there on the screen. So for example, if you have one button on the left-hand side and another one on the right-hand side, they can be rendered in parallel by the two cores. That's fine. However, if you have a large background, for example, the screen, which is just filled with a gray color, you can just do it with a single core because nothing else can be rendered before the background is actually filled. However, recently, meaning like 2 days ago, I just opened a pull request in LVGL to speed it up hugely, because with this new improvement, you can configure LVGL to split the larger areas into smaller tiles. For example, the whole screen will be divided into two areas. And if you have two cores, it's 100% certain that there will be one independent area because these tiles are independent, not overlapping. So always there will be something for two cores. I didn't have time to measure it on an ESP hardware yet. However, according to my measurements on PC, it was like 80% boost with 2 cores, and of course even more, almost triple speed with 4 cores. So it will be huge. I hope we will see the same performance boost on the ESP hardware as well. If not, we will make it work at the same level.
And talking about new features, the question here is, what is the current status of the development of the project creator and UI editor?
Yeah, great question. Yeah, we have recorded this presentation like a month ago, so a lot of things happened in the past. If everything will go according to the plans, we will release the project creator tomorrow. So it's in a pretty good shape already. You will be able to download it for Windows, Mac OS, Linux, and will be available on VS Code as an extension as well. So it's pretty close. And it's an important milestone for us because in this project creator, we have established the basics of the editor as well. Now, the whole tech stack, which is this multi-platform setup, is already working. We can access files locally. We can build up a UI in a single code base. So it's a very important step forward. Based on the experience of the project creator, we can start implementing the editor as well. Regarding the editor, the actual work is just in a proof of concept state at this moment. We have tried out the most important and critical things just to be sure that all these are feasible or our ideas really can be implemented. But the real development on the editor will happen in the upcoming months. We will share a release in each quarter publicly. So yeah, we will actively listen to your feedback.
Yeah, and talk about feedback in the UI editor. We have some questions here about how to be a beta developer or tester. Do you have anything to share about that?
Yes, I like to share my email address. Please write me an email and I would be happy to add you to the list of beta testers. If you can really join into this beta tester community, we can share the development versions more frequently, not just quarterly. And we would be happy to hear how it works on your end, if there are some unexpected crashes, how it works, if it fits your workflow. So there are a lot of things that we would love to hear from you. Just please send me an email to lvgl@lvgl.io and apply as a beta tester.
Perfect. So we are running out of time here. So there are still some questions in the chat. So Gabor, if you can answer the questions in the chat, I will be really happy, and as well the people who asked. So
Sure.
I like to thank you for being here, and so that's it. Thank you so much for being at the second DevCon you are. So you gave a talk last year and then one again this year. Thank you.
Yeah, thank you for the opportunity again. It was my pleasure, really.
Nice. And now back to the studio.
Thank you, Pedro, and thank you, Gabor, for those stunning insights into LVGL and how we can use it on the new ESP32P4.
Staying on the topic of graphics and multimedia, our next speaker is Mao Jianxing, who will give us a talk about ESP General Multimedia Framework, or ESP-GMF.
Now, ESP-GMF is a highly flexible framework from Espressif designed for memory-constrained IoT devices. Now, if you have to build applications with audio, images, and video with very little RAM, then this is the talk for you. Let's hear more about ESP-GMF from Mao Jianxing.
Hello guys, my name is Mao Jianxing. My English name is Jason. I'm the audio solution manager at Espressif System. I'm glad to share my content with you today. Before we get started, allow me to introduce our teams. Our team researches audio, video, and image algorithms, developing multimedia transmission protocols, design multimedia software framework, and integrates AI to create solutions for smartphones, children's education, home security, and robotic voice systems. Today's sharing is divided into 4 parts. Introduction to ESP-GMF, the components of ESP-GMF, the GMF workflow, and example and performance. The first part is introduction to ESP-GMF. What is GMF? Yeah. GMF, formerly known as the ESP General Multimedia Framework, is a general software framework developed by Espressif for the IoT multimedia field. It's offered highly flexible and adaptability, specifically designed for IoT chips with minimal RAM usage of just 7 kilobytes. ESP-GMF can be applied to audio, image, and video products, as well as data stream products. Let's look at this system diagram. The GMF core is the basic framework of GMF. It primarily consists of modules such as GMF object, GMF IO, GMF element, GMF task, GMF job, GMF pipeline, and GMF port. The GMF data bus provides as unified data access interface, while the GMF pool manages in-test elements and IO stream, and is used to create GMF pipeline. The GMF classes are specific instance classes of elements and IO streams. This chart shows the classy relationship of each model in GMF, highlighting its simple and flexible structure. GMF object is a basic class with its structure depicted in the figure on the right. The new and delete functions it provides allow inheriting classes to quickly create entity. The 3 modules, GMF elements, GMF IO, and GMF task, inherit from GMF object. The GMF IO classes is an abstract implementation of input and output streams, providing a unified interface to the outside. Common GMF IO implementations include Fire, HTTP, Flash, and I2S. Now, let's look at the components of the GMF. First, let's look at the GMF element, which is an important part of the pipeline. It provides consistent working function for each element, including open, process, and close operations. It also offers 4 port management methods and ways to access the functional capability of each element. GMF elements can derive various special categories such as audio elements and picture elements. Audio elements instantiated classes include encoder, decoder, EQ, mix, resample, and other audio algorithms. Picture elements classes include JPEG encoder and decoder, PNG decoder, and more. GMF port is the data input and output port for an element. An element has at least one port, and the port's connectivity is defined by the element itself. GMF method provides a way to access element function through a unified interface based on GMF args. GMF args is used for the parameter serialization of function. Please refer to the finger out on the right for its structure. GMF port is a connection port of an element capable of connecting to various types of ports, such as the callback function and the GMF database. GMF port has the ability to manage payloads, adjusting the size of the payload's buffer based on the element's connection and required data size. Additionally, it enables data addressing between elements. GMF data bus provides a unified data access interface, which used a query release to access data. Data transmission supports two transmission modes, zero copy and copy, as well as blocked and non-block access methods. At present, GMF supports three kinds of data bus, namely RAM buffer, P buffer, and block buffer. All three interfaces are thread safe, of which P buffer and block buffer data transmission are zero copy. RAM buffer and block buffer provide the blocking interface that can be called in different threads. GMF task is the thread that executes jobs. It takes job from the work list to run. When the job of the work list is executed, it will enter the idle state until new job is added. Job is the smallest unit to perform work. Job is divided into one time and unlimited times. Generally speaking, a pipeline has only one GMF task. A picture on the right is the basic workflow diagram of the GMF task. GMF pipeline supports pipeline cascading, allowing one pipeline to connect to another, with events from one pipeline cascading to the downstream pipeline. It also supports the sequential startup of event-dependent elements. For example, in a pipeline with two elements, a decoder and a receiver. Well, the receiver depends on the music information passed by the decoder. GMF pipeline will start the decoder first. The receiver will only start once the music info is available. This process simply operation without noise. The pipeline supports controls such as run, stop, pause, resume, and reset. The GMF pipeline is a model that operates independently with GMF. It handles events for connected elements and tasks, and is responsible for managing in and out ports. During operation, the pipeline also registers jobs for connected elements. Typically, a GMF pipeline consists of one GMF task, at least one element, one import and one output. The import connects to the input of the first level element, while the output connects to the output of the last level element. A pipeline can have one or more elements, limited only by physical constraint. GMF pipeline is highly flexible. Here are four basic pipeline applications. The first diagram shows a pipeline for decoding audio from a file and playing via I2S. The second diagram, the pipeline's input and output are not connected to ports, but used a callback function to a known user to provide the data. The third diagram illustrates a pipeline split into two parts, connected by a ring buffer in the middle. The fourth diagram shows two pipelines connected to a mixer pipeline, used for multi-channel mixing with a single output. The pipeline described here is more complex and is designed for intricate case involving shared data. For instance, during music playback, audio data needs to send to an AEC for reference. The finger shows a copper element with a single input and multiple outputs. Its output can be connected to multiple pipelines as well as other types of outputs. This part introduces the ESP-DMF workflow. Now, let me introduce the sequence diagram of the pipeline. When the pipeline run API is called, it invoke the run API of DMF task. The DMF task executes the blocking state and performs initialized tasks, including calling the running callback to open the connected in and out ports. After completion, those operations or running callback is sent to the application layer. Only after all those functions return does the pipeline run function exit. After the pipeline call run, it enters to the running state. During operation, if an element emits an event, the DMF task will notify the pipeline. The pipeline will then notify all connected elements of the events. Each element uses the event information according to its own requirements. If the element meets the operation requirements of an element, the element state will switch to initialized, ensuring that the elements will be added to the work list during the pipeline's later loading phase. Once all element tasks are added to the work list, the pipeline continues to run into a loop. Well, in the running state, calling pipeline stop can premature stop the pipeline's execution. Once pipeline stop is invoked, it will call stop on DMF task. DMF task will first clear the loaded work list. Then the pipeline will add the closed jobs of the connected elements to the work list. After all the closed jobs are completed, a stopped event will be sent to the application. Once all those operations are finished, the GMF pipeline stop will exit. The process of the finished and error are similar to those calling pipeline stop, with the key difference being that finished and error are triggered by DMF task itself without requiring user API calls. After finished and error occurs in the pipeline, GMF task will first clear the loaded work list. The pipeline will then add the closed jobs of the connected elements to the work list. Once all the closed jobs are complete or finished, and all error events will be sent to the application. After all those operations are complete, the GMF pipeline will stop running. Here is an example and a performance comparison. This is an example for playing music from SD card. Use the ESP-GMF. Let me switch to my code window. Here, the first line, we mount SD card and install the I2C drivers. And those code, we register the IOs and elements to the GMF pools. After that, we can new a pipeline with the name and in out port string. After that, we set the URI for the import. Here, we correct the GMF task for the pipeline. And here, we bind this thread to the pipeline. Call this line GMF pipeline run. We can run in the pipeline. I will build in and download this code to ESP32 S3 board. Wait a second. This is my test board. Okay, here we go. The sounds come from the speaker. Yeah, it's done. Yeah, this side, we compared the resource overhead of GMF and ADF on the ESP32 S3. For detailed data, please refer to the two tables. We tested the three audio source, SD card, flash, and HTTP. And each source, we have two pipeline structure, one using resample and one not using resample. So there are two test cases in total. The table shows the GMF saves an average of 29% in memory usage and reduce CPU loading by an average of 7%. This greatly simply and integration of audio functions into resource-limited chips. That's all. The above contents is my presentation. Thanks for watching. If you have any questions, please feel free to contact us through GitHub or our sales teams. Thank you.
Thank you, Jason, for those insights into ESP-GMF. So Annie, how has been your experience so far?
Sudeep, thank you so much for the question. I'm actually learning a lot, and it's an amazing experience for me. I have to admit, I am not very technical, and sometimes I want to learn, and I want to do it alone. I don't want to bother everyone around me. And I have a little secret of myself.
Oh, so what is this little secret that teaches you a lot when you're alone?
It's actually ChatGPT.
Oh wow, you're in luck, Annie, because our next speaker is Priyanka Matikshara, the CEO of Voltai. She's going to lead us through cutting-edge AI architectures, LLMs, and AI agents designed specifically for the semiconductor industry.
This actually sounds really interesting. I salute Priyanka, and let's go ahead and listen to her talk.
Hey everyone, welcome. Today in this talk, we're going to see from lab to fab why ChatGPT is cool but is not working in production. As the title suggests, we're going to be thinking about how to build and how to not build AI for helping in electronics design. I'm pretty sure that's in mind of all of us, and this is what the talk is going to be focusing on. So, who am I? I'm Priyanka. I'm the founder and CEO of a company called Voltai. We're based out of the Bay Area. I went to Stanford, met my amazing co founder there. We're both extremely passionate about the hardware industry and want to apply AI techniques to improve it and make it better. But I would say, most importantly, the thing that drives both of us the most is thinking about how we can build intelligence that is going to transform how the physical world is built around us today and how tangible objects that we hold today are going to be structured. So, who is Voltai? Voltai, we are a group of extremely talented and interesting individuals out of these institutions, like you see here: Stanford, Meta, Apple, Google. Um, some of us are from Berkeley, Cerebras, Snap. Um, our engineers are extremely smart. They're either ICPC medalists or Physics Olympiad medalists or International Olympiad of Informatics medalists. And yeah, we at the core are an AI company, and that's what we do. We build AI models for making electronics design faster, better, and easier. So let's now come dive right into the talk itself, which is training an AI co-pilot for electronics design. I'm pretty sure this is in the minds of a lot of people here today. We're talking about electronics design stack, the entire stack, anywhere from selecting parts to build a board, to writing code, to building the schematic, verifying the schematic, layout design, and testing the whole thing, board bring up, but also going deeper into the stack, assisting with chip design itself. And people have been thinking about using AI to automate or to make the development process easy in all of these different layers. Um, and what I'm going to be doing here today is actually a little bit of counter selling to tell you how to not build something. Because typically, when one wants to do this, what we would end up doing is, okay, let's take a large language model that exists out there, Llama, whatever, get a bunch of data that my company has, dump it into the model, throw a bunch of compute at it, set it on fire. At the end of the day, I'm going to get a model, and that's going to be able to, I don't know, do schematic generation for me or help me do a certain task in EDA. It's sort of the naive approach of how people go about it today. And it's not a bad idea. It's the first step. But I'm going to be here telling you how you can basically save your time and not do that, and why that would not work, and potentially what is going to work. So let's get right into it. The first thing for anything about AI is data. And let's talk about data in our domain. We're not talking about finance or legal electronics data is very unique for a certain reason. Chips and semiconductors, which is the building blocks of whatever we're going to be building, are very structured pieces of engineering. These are parts that could be complicated, that's okay, but at the end of the day, they're still very structured. They have certain peripherals, they have a certain way these peripherals interact with each other, they have their own constraints, and this is how they work. Take an MCU, it has the peripherals the way it interacts, it has a clock, it has memory, it has a CPU, and this is how it's structured. It could be complex, but that's what it is. So, okay, that's great. But this is how we represent a chip today. That is one microcontroller. It's a very famous automotive one, which is represented with 12,000 pages of documents. We're talking user manuals, reference manuals, architecture manuals, errata sheets, application notes. That tiny chip out there is shown in these many documents. The problem that's happening here is that that structured piece of engineering, which was the chip, is being represented in a very unstructured manner using these PDFs. These PDFs have all kinds of modality. They have text, table, crazy tables actually, images of this sort, code, so on and so forth. So this is where the tricky part begins, which is what we're looking at the end of the day. When you, let's say, take an AI model, Llama, whatever, dump it with all of these documents and say, hey, here you go. Now, like, tell me how this chip works, help me debug a system. You're actually not feeding it in information about the chip. You're feeding it in information about how human perceived that chip itself. It is just a bunch of text and documents that is being dumped, not the actual structure of the chip itself, which is a huge problem, by the way. So this is the first aspect to why you should not just take a large language model, dump all the data sheets to it, and be like, yep, here you go, work for me. The second thing we're going to be talking about is the model itself. Now, large language models, what are they supposed to do? Or how are they architected? These are transformer-based models, and these are models that have been trained on vast amount of data, internet scale data, to predict the next word in a sentence itself. So this is what they're meant to do. It's going to just say word after word, sequence out of sequence after sequence, and keep producing results of that sort. Now, this is a small problem for us because LLMs are amazing. They're fantastic for writing emails, for writing poems. But the problem is, what we just saw is they can only do one structure, which is one after the other, and they're not really good at understanding the complex structure that our semiconductor chips actually possess. So, what is the problem here? We're trying to teach a large language model what a circuit is. But a circuit is not a sentence. Like a sentence, a sentence could be, I am Priyanka, right? There is a start to it, there is a stop to it, there is a full stop at the end of it, then there's a capitalized letter in the beginning to say that that sentence began. So this is how sentences are structured. In a circuit, however, there is no start or stop. Like it's just a circuit, a complete graph, and there is no beginning or end to a circuit itself. So how do you represent this as a sentence? It's a really poor idea. There is, and in a circuit, components can be interchanged. For example, there's two parts that are connected in serial, like one LED after another. I switch both of them, it's okay. In a sentence, I actually cannot do that. That's going to break the semantics of it completely. Going back to the sentence, I am Priyanka, let's say I'm just going to switch it off and say, am I Priyanka? That just meant something completely else and it cannot be done. More reasons to why a circuit is actually not a sentence itself. So actually, let's look at this example. This is from a paper that came out of Google where people talk about the pitfalls of the next token prediction models. So a circuit, as I said, can be represented as a graph, of course, because there are different components, which are the nodes, and they're connected to each other through an edge, and it's just a graph at the end of the day. And as we see, this here is a very simple graph, it's a toy graph, and they talk about how large language models have a hard time understanding the structure of this graph. So let me demonstrate what's going to happen here. So let's say we have a problem statement where the model is at 4 and it needs to reach 7. It has 3 paths that it can take: 1 to 9, 3 to 5, or 2 to 7. So how would a human know which paths to take to reach the 7? Is you basically go ahead in time or in structure. You see, okay, 7 is there, which means I need to take 2. And hence at 4, I'm going to make a decision to take 2 and not 1 or 3. Hence, I know I can reach 7. And this is something a large language model today cannot do. As we saw, it predicts word after word. When it is at 4, it would be like, I'm just going to say something, maybe 1 or 3 or 2, and then just go to the next one. It cannot go into the future, see what is happening, come back and make a decision. It just has to keep saying what it has to say. This is one of the primary root causes for hallucination as well, because hallucination is a very common problem. The model says something that sounds right, but is actually not right. Why do we have all of this? Because the model starts by saying something. It has no visibility into the future, and it just keeps rambling, so to speak. So when at 4, it's just going to take a path, and if it's wrong, it's wrong. You cannot do anything about it. So that leads to the second point, which is, let's say it's at 4, it just chooses 1 because it did not know which to actually choose because it couldn't see through in the future. And at 1, it realizes, oops, the one after me is 9. It's not the path I wanted to take. Can it go back and switch its decision and say 2? It cannot. Once it has taken a path and it has predicted the next token, it just has to keep going from there. And this is exactly why we see hallucinations happen. So this is a very simple example of how LLMs have a really hard time dealing with graphs itself. And we just saw circuits, chips, all of these are fundamentally graphs. And hence why you should just not throw a bunch of data at these models, data sheets especially, which are just like literally text representation of these circuits, and be like, hey, do this for me. Not the best idea. Okay, so since so far I've complained about what one should not do and what one would not work, let's talk about what actually works. So drum rolls here. So what we've noticed that actually works is, first, let's talk about the data itself. The data needs to be transformed from not language like English in which you represent the chip in the document, but into something else, which is a semantically tokenizable language. AKA, this is the representation of the chip that actually captures the structure of the chip. It needs to capture how different peripherals interact with each other, how these interactions in different layers interact with each other, so on and so forth. So that's from the data side. From the model side, what should the model do? These are 2 very important things that the model needs to do. The first one is understand human preference. I'm going to come to this in a second. Second one, as we just saw, it needs to understand structure. It just cannot be freestyling its own way, generating tokens after tokens. And so these are 2 very essential things the model needs to be good at, and use the data, as we said, in a semantically tokenizable manner to be able to produce models that can actually truly fundamentally understand how a chip or a circuit works to be able to give a valid response. So what do I mean by saying models that understand human preference? At the end of the day, we're building co-pilot models. These are models that are going to be working with humans to be giving a result itself. Co-pilot needs to have another pilot, which is the human. So the model needs to be really good at working with them. So that's just one thing. That means a lot of sub things under it. First thing is, a response it gives needs to be very clearly explainable and justifiable by the model itself. It cannot just say something the humans out there wondering, how did it come up with this, or why did it say this? That's not cool. It needs to exactly be able to explain its thought process behind that reasoning. Hence, the reasoning needs to be more clear. That's first step, and it's clearly not going to be possible if you're just like, saying words after words and not being able to go back or predict the future and justify why you made a decision a certain way. Second thing is, these models are not smart yet. Yes, they can do certain things really well, in fact, slightly better than humans. But at the end of the day, they're always going to have to be learning from the humans. A model that's just out there claiming to help humans, saying, I have 80% accuracy, is actually a dead weight. These models are capable of doing a lot more. And one big reason they're capable of doing a lot more is that they can learn from the human behavior itself. So let's say there's a human that is trying to let's design a schematic or whatever. And this copilot is helping the human as they're designing the circuit. And at some point, the model says something, but the human makes a different decision. The model needs to learn what happened there. It was a trade off that the engineer made cognizantly based on the problem statement. In spite of what the model might have given as the most optimal solution, they made a trade off, keeping something in the future in mind. So that's something that the model would have to learn. What is the difference between a good design and a great design? That is something a great engineer can produce, a model cannot, and the model needs to learn what differentiates a good versus bad versus great design, and how can it produce greater ones more often. So these are reasons why the model needs to be really good at bonding with a human, working towards them in tandem, and learning from every single implicit step of theirs to improve itself. Model that understands structure, we just saw exactly why it's essential. These are models that needs to be trained on the structure of the chip itself or the system itself. And it needs to understand this structure, hence it can reason and actually give meaningful results that are not just produced for the sake of being produced, and also can handle more complicated levels of reasoning and multi-layer ability to reason through different things and infer, so on and so forth. So yeah, we've actually put these models in deployment. We've built models that have good understanding of human but can also understand structure in production, assisting engineers. And these are different feedback that we've received from them. The first one says, it used to take me 2 hours, now it takes me less than 20 minutes. For this engineer, we deployed an initial version of the model. It kept learning from their behavior, and eventually it has been a huge time saver for them. I think the second code is very important, and it's something that's very essential for enterprises, which is it feels like having my senior engineer right next to me when I work. This is powerful because what happens at the end of the day is these models bridge the gap between the seniors and the juniors within these companies. So, a senior over time has accumulated a lot of knowledge. They've learned a lot of lessons by looking at different things, but they also have certain facts in their head. And anytime a junior doesn't know something, they have to reach out to them, wait for them, and they need to take time off their work to come mentor, train, and help this junior out. However, if this intuition and also fact and knowledge and years of experience could be put inside an AI, because this is an AI that's constantly evolving like a human, and now if you give this AI model itself to a junior engineer, you have bridged the gap essentially between a senior and a junior. And this is extremely powerful in terms of not just reducing time, but letting people, engineers especially, do things that they were previously just absolutely not able to do. For juniors, it would be onboarding really quickly and very quickly being able to perform activities with the senior engineer's level of intuition right next to them. For senior engineers, it's of course not getting distracted by coaching or mentoring and just like doing things with a lot higher throughput, because now all of their simple tasks can be handled by this AI model that has learned from them itself. So this is something that's extremely powerful. And of course, we've received a lot of other really interesting feedback from our users. And this is another interesting thing that needs to be kept in mind when one is trying to look at or evaluate AI models for the application in this industry, which is the accuracy, or which is the ability to produce results that can be used in production. So what do I mean by this is we're not talking about creative writing or poetry here. The engineering has a certain result, and that result has to be achieved. And in order to do that, you cannot just rely on foundation models, because these are generalist models. They can do a whole bunch of tasks really, really well. But you need these models to do a certain task extremely with very high precision. Let me give you a simple example. There can be a foundation model for electronics. However, if the task is going to be layout design, or if it's going to be firmware code generation, if we don't even have humans today who are like extreme experts in doing both of this. We have individual experts doing both of this today. A layout engineer would not write firmware, vice versa. So in this case, how do we handle such a conundrum? Is by building technology called first mile and last mile models. First mile models are models that are generalist. They can take you from 0 to 80% accuracy very, very quickly. And the last mile models would take you from that 80% to 100% to the ultimate precision. And these are models that are going to be good at just that one downstream task, not at different downstream tasks. The narrower, the better for the model itself. And these last mile models can be pretty much anything from traditional machine learning models to deterministic physics engines and whatnot. It doesn't even have to be an AI, but the first half would be a foundation model that would take you from 0 to, let's say, 80 or 90% fairly quickly. And so far, whatever we've seen in this talk is how do you build that foundation model, not specifically the last mile models, but the last mile is going to differ heavily based on different use cases. But yeah, and these are how things have been done up to today. We've built these models, we've seen them work extremely well in industry. A whole slew of customers across the stack, anywhere from semiconductor companies to tier ones to OEMs, have been benefiting with it. And that being said, I strongly believe there's a new era of models which we are working on right now, by the way, which is going to be extremely revolutionary, and their potential is going to be incredible. And these are non-autoregressive models. So what I said so far, which was, hey, don't take Llama and just like, dump a bunch of data and expect it to work, Llama, GPT, whatever, but actually build models that can understand the structure and human heuristics. Those were still autoregressive models, and they still had the sequence to sequence behavior, but we were just combating that by structuring the data differently and letting the model do tasks differently. However, there are certain types of models that are completely non-autoregressive in nature. These are models that are fundamentally not next word predictors. They work very differently, and these are also models that are trained on multimodal data. As we saw, data in this domain is very varied, anywhere from text to tables to schematics to pinout diagrams, clock diagrams, a whole slew of them. How do we build a model that can understand and reason over all of these modalities while also not being next token predictors is what these non-autoregressive models are. And this is something we're working on. I strongly believe, our team strongly believes this is going to be the future. And we hopefully will be around here for next DevCon presenting this. And also not just presenting, but seeing the impact of this model in a lot of different presentations and exhibitions out here. But yeah, thank you so much for listening, and I appreciate it. If you have any questions, feel free to always reach out. We are a bunch of AI engineers, super passionate about the electronics industry, so we're always here to talk about anything AI. Thank you so much.
Thank you, Priyanka, for the amazing talk. Sudeep, I'm starting to notice that our audience coming from far away online. This year, actually, I visited Brazil for the first time. And I would like to say hello to them into their own language. Olá, estou muito feliz em ver a comunidade do Brasil aqui.
Well, Annie, it looks like your Brazilian project is coming along really nicely.
Thank you so much for noticing. In Brazil, I actually had a very good teacher guiding me through the language, who happens to be our next speaker.
Aha, I know Rodrigo is a great Brazilian Portuguese teacher, but he's also a great Arduino teacher. This year, Rodrigo is going to talk about how can you build an Arduino sketch inside ESP-IDF using an ESP-IDF component. He will show us how we can use Arduino libraries in IDF and help us understand the interoperability of Arduino and IDF. Let's have a listen in.
Hello, my name is Rodrigo Garcia, and I work with ESP-32 framework development within Espressif. Today, we will talk about how to build Arduino as IDF component projects. We'll talk very quickly about Arduino. I will show you an example. We'll talk about how to add libraries and how to use CDC and log messages. What is Arduino? What is its relationship with IDF? Arduino is a project that makes easy to use embedded software that has an IDE integrated with a toolchain and bootloader, which makes very transparent for users to integrate that parts. Users will use an IP, which is the Arduino API, and that API will allow those users to include modules, external hardware, such as sensors, displays, and LEDs. That was initially thought about using for designers and artists, but it got very popular, and today it's used in every place. So the API is very easy to use, and it deals with digital pins and analog pins as well. It allows you to communicate with different modules, and it also is based on C++. We will not talk about Arduino here, but you can see many tutorials and examples provided by the community that are out there in the web. The relationship of Arduino and IDF is that there is this Arduino HAL level in the middle, which is a middleware that makes the communication from the upper level, which is the Arduino API that has all the APIs for Arduino, and the lower level, which is IDF itself. All of that has also free RTOS available for you. If you need more information, you can go into that specific link. Arduino as component is basically an IDF project. It uses IDF tools. In terms of IDF, you have your project, which usually has an SDK config file. This file is automatically created when you're building your IDF project, and it's based on the settings for each one of the components of the framework. Arduino has its own SDK config, and you can find that SDK config for the version 3.04 in the first link, and for the version 20x in the second link. You can use that SDK config in your project if you want to. In particular, the examples here are for the S3, but you'll find all the SDK config files for all the other SOCs. Once you have your SDK config there, you can use IDF PY menu config, which will open a window that allows you to browse through all the settings. You can change them, for instance, partition, scheme, or flash size, and then you save it into the new SDK config file, and you start building your project by setting the target, which actually was done before, and then you just go through a building process and flash your chip. This is exactly how we do with an IDF project. There is no difference. IDF and Arduino has a very specific relationship in terms of versioning. So each Arduino core has its own IDF version. You can check that on the release notes from Arduino. Here I have a list of the different core versions and the IDF versions used by them. IDF projects usually use the ESP component registry, which is a central repository for all the components that are provided by Espressif and also by the community. You can check that in that link. In order to add a component, you will modify IDF component.yaml file and declare all the dependencies there. In particular, Arduino framework is one component in the registry. So in our examples today, we will use that. You can also clone your own Arduino in the components folder of your project. In that case, you would not use the component, the managed component here from the registry. Let's show you a basic example now. This is the folder structure used by Hello World, which is the minimal example possible. You have your project folder here with different files and one folder main, which will contain all the source code. We'll go through all the files in a minute. So the project CMake list txt file is a generic and global, let's say, declaration of CMake for your project. Remember that IDF projects are built using CMake. So you will request a minimal version. We'll include all the tools necessary, which are IDF functions for CMake, and we'll declare the name of the project. We also have the SDK config default file, which has all the SDK settings for our project. Those settings will override the component settings coming from IDF. In our case, we have the auto start Arduino as yes, which means that it should use setup and loop routines to start the application, the sketch itself. And also we set the frequency of FreeRTOS for 1 kilohertz, which means that each tick will take 1 millisecond. If you need to add more configuration, you can to that file, no problem. And if you need to check what are the differences between what you have added here and what comes from IDF framework, you can use the command idf.py save def config, which will automatically create this file for you. We have, as I said, the main folder, which has all the source code of your project. There we have an IDF component YAML file, which might declare the dependencies of all the components from the registry that we might need in our project. In our case, we are just declaring the Arduino framework is our dependency, which will make the tool to download it automatically from the registry. We can pick a version, saying what is the version and the clause version. Here in the example, I'm using the latest one by using a star as version. It also has its CMake list txt file, which declares all the source code. In our case, we have just one file, which is main CPP, and this main CPP has the sketch itself. And any include directories will be in the same place of the main folder. If you have more source code, you need to declare the list here. Our main CPP file, which is our sketch, is very simple in our case. It has the setup and loop functions, basic from Arduino, and that only opens the serial port, prints hello world, and waits for 1 second. It will be done in a loop, meaning that it will print hello world every second. Once you're done, you need to use the IDF tools to build the project. In order to use the IDF tool, which is idf.py, all we need to do when we just create this project is to set the target, which will be ESP32S3 in our example here, and execute flash monitor or just build in order to build it, or flash and see the output of the serial port. If you change your target, it might require you to remove the build folder and also to set again the target. Don't forget to delete the SDK config file, because that file has a declaration about what is the target. So when you build it, it will take the target from the SDK config file. So if you change the target, delete build folder and SDK config file as well. You can use menu config to change any setting again if you need to. That's why keeping your default settings in the SDK config.default is important. Let's talk about how to add libraries to Arduino project. In the case of Arduino as IDF project, we have three kinds of libraries. One is the libraries that are embedded in the Arduino framework itself. There is nothing to be done here. All you need to do is use them. You can use the examples from the Arduino core in the GitHub and run them, build them directly from there. Everything is set up already. You might need to use some external libraries from Arduino community, which are those used for displays, LEDs, sensors, and some other external hardware. In that case, all you need to do is create a component. For that, in your project folder, you should have the component folder. In that component folder should include a folder for the library. You clone the library there, or you copy the files or the folder, the whole structure there. The only thing you need to add is a CMake list txt in order to provide CMake with the list of source code for that particular library. The third way of including a library into your project is using the registry. The managed components here can be used because we can mix IDF and Arduino code in the same code. In order to include any component, you just declared it in the IDF component YAML file, which is in your main folder. Everything that you bring from the managed components should never be touched or modified. It's managed by the system. So if you need, for any reason, to modify your component that comes from the registry, you need to copy that from the managed components folder to your components folder, which is your local group of components. So there you can modify anything. If you try to modify any source code in the managed components folder, the system will complain about it and will not allow you to build the target. This is the structure, the folder structure for the libraries. So as you see, you have the same I have talked before in the example, in the Hello World example. And we have this extra components folder where we have one folder for each one of the libraries we are using. You can have many libraries as you want. And for each one of the libraries, we should have one CMake list txt file that will say what are the source codes for that library. This is an example where we are using the Wi-Fi Manager library, which is an external library. You can see the GitHub for that library. And all we need to do is go to the folder for the project, create the components folder, go into the components folder, and clone that library there. In particular, that library has already a CMake list txt file, but we need to modify it. The modification is just telling the system where exactly is the Arduino framework folder. Because we are using the registry, and the registry will install automatically the Arduino framework into the Espressif _Arduino-ESP32 folder, which is under the managed components folder of your project. If you, for any reason, use your own copy of the Arduino framework in the components folder, you should replace that name by the name of the folder you have cloned your Arduino framework into. Also, it might be interesting for you to add in the SDK config default file one setting, which is to tell the system that should not care about the idle task for CPU 1. This is the one which is in the middle here on the screen. This is interesting for the ESP32 and the S3 because they're dual core, and the system might complain because CPU 1 is idle, a task is not being reached, mainly because of Wi-Fi. So that is also in the SDK config from Arduino as default there too. But in your project, you might want to declare that explicitly through the SDK config.default file. Now we will talk about how to use the USB CDC. When we have a Arduino's IDF component project, we can use the serial object, which is usually the UART0 port. Some boards, they might have native USB port there, and you might, in that one, might be the only one port, by the way, of that board. You might want to use that port in your project. In order to do that, all we need to do is to declare two symbols, which is Arduino CDC on boot equals 1, and the Arduino USB mode equals 1 to tell it it's using hardware CDC. If we declare that it's 0, it will use the USB OTG. The hardware serial is a specific implementation in hardware for only CDC class of USB. It's available in the C3, C6, S3, H2, and P4. And when you do that, two defines, your serial symbol will be attached to the hardware CDC port. In order to declare those two defines, you go to the cmakes list.txt file from your main project folder and add those two lines that will just do as define those two symbols as 1 and 1. That's all you need to do. The way how Arduino works with that is that it has a hardware CDC class in its framework, and that hardware CDC class has an object called hardware CDC serial. When you set Arduino CDC on boot to 1, serial will be defined as hardware CDC serial object. Therefore, it will act exactly as the serial from Arduino, but everything will be outputted to the CDC port. Don't forget to set the mode to 1 in order to use hardware CDC. When you upload any sketch using the USB port, it might be necessary to make the SoC enter into the boot mode, into download mode, I mean. In order to enter into download mode, you need to hold the boot button and then pulse reset, meaning that you press it and release it very fast. That will make the SoC enter into download mode. You download your sketch and your firmware to the SoC, and at the end of the operation, you just press reset to start the firmware. If you want to use OTG USB, which is only available for the S2 and S3, it's very similar to the other process, but you need to set the mode to 0 in the cmake list.txt file. And also you need to add the tiny USB component here, which will be cloned. How to clone it? You basically go to your project folder and execute those two lines of command. You will clone ESP Arduino lib builder into the project folder, and then you clone the tiny USB project into that too. That's all you need to do, and just build it and flash it. Now we'll talk about debugging. Debugging meaning that how you send log messages out. When you talking about the log messages, you have three options. One is the bootloader messages. The other one is the IDF component messages. And the third one is the Arduino log messages. There is one log level for each one of those three different places. So in order to modify that, you can use idf.py menu config, go into the menu, and go through these different layers of the menu and modify the level of the log messages. The other way to do that is also by changing your sdk-config.defaults file to include what is the level for each one of those parts. This is an example of how to change the debug level for Arduino. You selected, this is the menu config screen, so you just selected Arduino configurations, you go to the debug log configuration, the full log level, and you'll see this screen. You can select one of those levels, which means no output at all, error messages only, warning messages, info messages, debug, and verbose. You just go out, save it, and build your project if you need. How the debugging works with Arduino in particular? Well, the serial object, anyone from 0 or 01 or 02, which means you are 0, you are 1, or you are 2, you can set one of those to output the log messages here. And in order to do that, you just use this method, which is set debug output to true, using the serial object that you want to use for login messages. In case you're using CDC, remember that serial will be the CDC port, OTG or hardware serial that you're using. In that case, the message will be outputted to the USB as well. In some cases, you might want to use only 01, which means UART 1, or 02 when that is available, as 02, and output on those other ports, other log messages. You can select the level of the log message by using the log dash underline the level. So error is E, warning W, info, debug, and verbose. When you set the level on the menu config, only the messages that are on that level will be outputted. All the others will not. So you need to select the correct log level that you want. This is all I wanted to talk to you, and I hope you have enjoyed. This presentation is available in this link in the GitHub. And also there are other examples I have exposed here, there as well. You can just clone that repository and go into each one of the examples and build them and look into how it was done. You can see all the configurations I have talked here, there as well. Thank you for watching, and now we go to the Q&A session. See you.
And here we are for another Q&A session. And directly from Brazil, we have Rodrigo. Hi, Rodrigo. How are you today?
Pretty good, thank you. How are you doing, Pedro?
Yeah, I'm fine. Thank you. Thank you for your question and for being here answering the questions. So we have here 3 questions. Should we start?
Sure, please go ahead.
Nice. All right. So the first question is, when it is better to use Arduino as component instead of just using the Arduino IDE to build an application?
Okay, the answer is about if all you need is already in the framework, how it's done in the IDE. So for instance, when we are using the IDE, the Arduino IDE, all the libraries from IDF, the components there, and everything else is precompiled with a setting, with a pre-established setting for IDF. So you cannot change anything. So if you try to change SDK config directly in the files from the Arduino IDE, it will not generate any effect because all the libraries are precompiled. So there is no way to change actually any behavior of IDF when you're using Arduino IDE. In that case, if you need to change anything or create some different behavior, or you want that library to do something different, or you want to set some specific, for instance, Wi-Fi sizing for, let's say, the buffers, or you want to change any characteristics in TCP/IP, or you want to maybe change anything, for instance, all the prior talks about maybe doing something related to speech recognition, anything like that, or you want to change your particular characteristics there, you need to go with Arduino's as IDF component, because there you can use menu config, all the tools from IDF, and change any settings from the components, which will, of course, reflect in your final application. So that's why you should use them.
Perfect. Thank you so much for your answer. The second question we have here is it possible to build an Arduino as an IDF component application using Windows?
Yes, sure. It's possible to use Windows, Linux, and macOS as well. In the case of Windows, it is possible for sure. There is IDF for Windows, for the command com, let's say, itself. And also you can use it, WSL, which is the Linux module from Windows in order to build them. The only difference is that when you're using, let's say, Windows directly using the command com shell, let's say, you are able to reach the COM ports directly, the serial ports directly through the COM number, right? COM4, COM3, or COM whatever. When you're using Linux in Windows, which is the WSL, you need to use another tool which will export actually that serial port and USB device maybe to the Linux sub module, and then you can use the -dev -tty whatever that is available there to maybe flash your application or even read the serial port and see the output. So it's possible for sure.
So basically, we can use Windows, Mac, or Linux, and all will be good.
Yeah, everything works.
So nice. So thank you so much. We have one more question here. Can I add my own Arduino library to the ESP component registry?
Yes, sure. It's possible. The component registry is open to the community, so anyone can add and contribute there. So let's say that you create a new Arduino library. It's possible to, of course, add it to the regular Arduino list of libraries and also to the ESP registry as well. But remember to set Arduino's dependency in that case, because of course, most probably that library will use Arduino calls, and the API will be available only if you have Arduino's component there. So if you set the dependency there to Arduino, most probably that will make clear to the users and also describe that as an Arduino library. The users will be able to include that as a registry component, and that will show up in the managed component folder and as a regular like registry library as well. So it's possible. People can do that for sure. And I would say that would be very nice, by the way.
All right, so thank you so much for your answer. I see no more questions here in the chat, but if you want still to ask something, we will answer later by the chat. So Rodrigo, thank you so much for being here, for your talk, and that's it. Do you have anything else to say?
Yes, well, that Arduino's components is a very powerful tool. So everybody that's looking into maybe going deeper into the process should try it. I think it's worth it. Go ahead.
All right. Thank you so much. Now we can go back to the studio.
Thank you very much.
Thank you, Pedro, and thank you, Rodrigo, for that fantastic session. So Annie, are you ready to learn some advanced concepts about the RMT peripheral of the ESP chips?
Yes, I am very much interested in learning that.
So Annie, do you know that the RMT peripheral, or the receiver transceiver peripheral, it is used to send and receive IR signals on Espressif chips, but do you also know that this peripheral can be flexible enough to encode a multitude of other signals? So to let us know how you can use this RMT peripheral as an encoder in your applications, we have Mao Shengrong from Espressif Shanghai with the next talk. So over to you, Mao.
Hey, welcome to Espressif DevCon24. My name is Morris. I'm working for Espressif as a software engineer in the chip support team. Many applications require unique interfaces that might necessitate sacrificing an SPI or UART controller. However, with just one channel, the RMT peripheral can drive your LED strip, D-short protocol motor, and even multiple one-wire bus temperature sensors. To achieve this, you need to create your own RMT encoder, which will guide the hardware in translating your application data into RMT symbols. In this talk, we will focus on the ways to construct an RMT encoder. Okay, let's get started. First, I will reintroduce the RMT peripheral by examining the IP block diagram. In this presentation, we will focus solely on the TX channel, as the RMT encoder is designed specifically for it. This includes how to allocate, configure, and send data using the RMT channel. Next, we will discuss how to construct your own RMT encoder. There are two traditional callback function. Following that, we will explore some impressive examples implemented with different RMT encoders. Finally, we will address some limitations of the RMT hardware and how to mitigate them. And of course, your feedback is always valuable. From the block diagram, we can observe the followings. All channels share the FIFO RAM, which is divided into multiple blocks and can be accessed by either the CPU or DMA. All channels use the same clock. For high resolution, select the PLL as a clock source. For low power consumption, choose the internal RC oscillator. The TX channel contains a counter. Set the divider based on the desired resolution. The output signal passes through the GPL matrix to the I/O pad. You can even modulate a high-frequency carrier onto the output. Next, we will see how to translate these hardware features into driver APIs. RMT hardware has significantly evolved since its first generation. For instance, channel 0 can function as RX on ESP32, but on ESP32S3, it can only be configured as TX. This inconsistency complicates writing a code that works across all ESP targets. Therefore, our driver does not allow you to designate a channel number. Instead, it searches for an available channel based on the requirements set in the driver configuration. Yes, this is the so-called factory design pattern. First, we select a clock source for the channel. If you want to install more channels, ensure they are set to the same clock. Otherwise, the driver will return an error. If the clock source is not a concern, just use the default one. Next, set the channel's resolution, which is the tick rate of the internal counter. A higher resolution results in a more accurate timing. Crucial parameter that should be set according to your application requirements in implementing the RMT encoder. Then choose a GPL number for the channel. The GPL number is the output pin of the channel. You can select any GPL number, but ensure it is not used by the peripheral. Set the size of the memory block used by the channel. A larger value means fewer interruptions to the CPU, providing more stability in environments with high interrupt latency. set the transaction queue size, which determines how many transactions can be pending in the background. Finally, configure additional flags for final control of the channel, such as leveraging the DMA functionality. Now we can allocate the channel object, and the driver should return a handle. Please note, there is a kconfig option called config rmt isr iron safe. If enabled, the RMT driver can also operate when the flash cache is disabled. For example, when you're saving some data into the MBS state partition, with this kconfig, the driver will always allocate the channel object from the internal RAM. The driver includes a state machine, so you must call the driver API in a specific order. This reduces the risk of putting the RMT hardware into an undefined state. For example, calling RMT enable before starting a transaction, because it enables essential system services like interrupts, DMA, power management. Here, if you call disable first, then enable again, the driver can cancel the current transaction and start a new one from the queue. The transmit function is the front end where you prepare the data buffer and set transaction-specific configurations. You can specify the number of times to repeatedly transmit the same user data. Be cautious with the value -1, as it signifies an infinite hardware transmit loop. You can also set the idle level, which refers to the state when no transaction is in progress. The transmit function is non-blocking. It constructs a transaction descriptor and pushes it to a transaction queue, then returns. The real job will only start working once all previous transactions are completed. If an infinite transaction is in progress, the only way to stop it is by calling RMT disable. We've covered all the basic APIs you need to know, from allocating a TX channel to starting a transmission. What is an encoder here? How do I create an encoder from scratch? In the encoder driver, we use a design pattern known as a composite pattern. This pattern allows us to reuse the existing RMT encoder as a combinator. By chaining these combinators, we can create a new encoder. The public interface defines two crucial methods, the encode and the reset. The encode method is a core algorithm where the logic to pass user data into RMT symbols is defined. An RMT symbol is a 32-bit integer that represents the duration of a specific logic level. Let's dive into the encode method. The primary data here is the raw data provided by the user, such as the channel number of a TV. The encode function must correctly return an encoding state, indicating whether the current encoding section is complete and if the underlying FIFO memory has free space. This function is often called from an ISR. It's also recommended to play IRAM to achieve high performance and reduce interrupt latency caused by cache miss. Please don't spend too much time in the encode function, as it runs in an ISR environment, and prolonged execution may lead to an interrupt watchdog timeout. The RMT driver includes some native encoders that simplify the construction of a more complex encoder. Let's explore these further. The first type is the copy encoder. As the name suggests, it transfers data from the user to the hardware file in a ping-pong manner. This encoder does not perform any format conversion. The user data must be an array of RMT symbols. Here is the code snippet to create a copy encoder. You might wonder, when should copy encoder be used? The answer is straightforward. It is suitable for any scenario requiring encoded data. It can be used for a leading code in NEC protocols. Next, let's delve into the concept of bytes encoder. To create a bytes encoder, follow these steps. Define the representation of bit 0 in the RMT symbol format. Similarly, define the representation for bit 1. Decide whether to transmit the most significant bit or least significant bit. Finally, obtain the encoder handle by calling the create function. Now, when should you use a bytes encoder? If you have a byte stream to send and are aware of the utilizing the byter allows you to convert the data bytes into an RMT symbol stream. A core use case is converting an RGB buffer into RMT. Now that we have both the copy encoder and the byte encoder, create a more sophisticated encoder. Explore the general steps involved in designing RMT encoder for driving an LED strip. Begin by defining a struct type specifically for the LED strip encoder. The encoder should inherit an interface that we discussed in the previous slide. Additionally, we aim to reuse the bytes encoder and the copy encoder. The bytes encoder handles encoding RGB data, while the copy encoder will translate the reset code. We store the reset code in the struct for convenience. Since we cannot encode all data in a single step, we will need a variable to track the current encoding progress. Next, let's provide a factory function to create an encoder and its handle. We call a help function to allocate the memory for the encoder. Configures the bytes encoder to align with the bit definition of the LED strip. Construct the coder and create the RMT symbol that serves as the reset code. Don't overlook the implementation of essential methods for the RMT encoder. There are 3, with the encode method being the most critical. We will dive into it in the next slide. Find the encoder handle to the user. In accordance with the LED strip protocol, during each refresh cycle, we need to transmit RGB data for all LEDs, followed by a reset code. Now, let's dive into how this sequence is implemented within the encode method. Keep in mind that the LED encoder inherits the base RMT encoder interface. Therefore, at the outset of our encode method, we perform a polymorphism to convert the base RMT encoder instance into an LED strip encoder instance. Once we have the LED strip encoder instance, we can retrieve the bytes encoder and the copy encoder from it, both of which we created during the pre-allocation function in the last slide. The crux of the encode function lies in design a state machine. For the LED strip, the state-machine transition is straightforward. First, transmit the RGB data, and then set the reset code. In the switch case, the branch corresponding to case 0 handles the encoding of the RGB data. It simply invokes the encode method that provided by the byte encoder. The encode method is responsible for reporting the current encoding progress. Therefore, we check the value of the returned session. If it indicates that encoding is complete, we proceed to the next state. However, if the byte encoder yields due to insufficient space in the underlying FIFO, it must also yield. It's critical to propagate the encoding state back to the caller. Additionally, we have another switch case branch that performs a similar task, encoding the LED strip reset time using the copy encoder. Finally, upon returning from the encode function, we provide information about the current encoding progress and the number of IMT symbols generated. Combining the copy encoder and the byte encoder doesn't necessarily allow us to create all types of custom encoders. Instead, we have another native encoder called the simple callback encoder. As the name suggests, writing an IMT encoder becomes as straightforward as creating a callback function. The key to allocating a simple encoder lies in specifying the callback function. When examining the callback function closely, you will notice that it has a parameter list similar to the encode method. However, there is a crucial difference. Now, you also need to manage memory size. User can fine-tune the encoding process with greater granularity, but this comes with increased responsibility for memory safety. Let's write the encode callback function for the LED strip again. At the beginning of the callback, we typically perform parameter check to ensure that the remaining memory size can handle the task. Next, we translate RGB data into IMT symbols and write them to the symbol stream. In the previous slides, this step was handled by the copy encoder or byte encoder, but now you will need to handle it by yourself. Finally, don't forget to translate the reset code. How to choose between combinators and callbacks? There are trade-offs between these two programming paradigms. Combinators provide a straightforward way to compose functions. It encourages modular design, allowing you to reuse existing building blocks efficiently. Callbacks offer fine-grained control. Developers can manage execution flow at a granular level, which is essential for certain scenarios. Callbacks give you direct access to underlying mechanisms, but this can be more error-prone. Handling callbacks correctly requires careful attention to avoid pitfalls. Generally speaking, the combinators are well suited for complex encoding tasks where composition and abstractions are critical. The callbacks are ideal for simpler encoding needs, especially when precise control is necessary. By the way, the callback encoder is still integrated within the IMT encoder architecture. You can even chain the callback encoder with other native encoders. Beyond the previously introduced LED strip, we can utilize IMT for various other applications. The D-short protocol interface for ESC. This includes a D-short protocol encoder and leverages IMT's hardware loop function, enabling the driving of a brushless motor with minimal CPU utilization. the open-loop precision control of step motor. In this application, we construct an IMT encoder that generates precise PWM pulses, adhering to the S-curve characteristics for smooth start and stop of the step motor. The one-wire temperature sensor, unlike implementing using GPIO bit banding, the IMT-based one-wire bus can operate stably in an RTOS environment. It's unaffected by context switching. All hardware has its limitations, and RMT is no exception. During the development of the RMT encoder, we might encounter this issue. Why does the RMT transmit more data than expected? The root cause is the hardware transmitter reads from the memory before the encoder updating it. If the RMT encoding process spends too much time or is delayed by latency, the transmitter that are outdated. The issue is hard to eliminate because we can't command the transmit to pause and wait during one transaction. But this issue can be mitigated by employing the following strategies. We can increase the memory block size. We can place the encode function in the IRAM. We can use the DMA feature, or we can even install the IMT driver on a different CPU core. Thank you for joining us on this exploration of IMT. This presentation is the surface. May it ignite your curiosity and inspire further development. Feel free to share your experience in writing the IMT encoder on our ESP32 forum. And don't hesitate to report issues on our GitHub. I wish you also enjoy other topics in the DevCon 2024. Thank you for watching. Bye.
Thank you, Maurice, for that detailed and insightful talk about the RMT peripheral.
So Deep, one thing that I would like to add, I want to say thank you to our speakers and our DevCon broadcasting team for putting the effort, and we really appreciate the feedback from the audience.
Speaking of feedback, there is a small surprise from our side. As you know, if you could give us feedback via the feedback form, you enter into a lucky draw. We will draw the names of 5 people at random who will be sent a dev kit from Espressif. So please leave us a feedback and you may win a dev kit. With that, we will take a short break of 10 minutes and we will see you on the other side. Welcome back to Espressif DevCon24 Day 2. We have had some amazing talks so far, and I would like to thank all our viewers for joining in. Let me take this opportunity to remind you to please like and subscribe to our YouTube channel, and I would encourage you to ask questions and share comments in the live chat. So Annie, what is next on our agenda?
One of the things that I like about our team, Sudhit, is how diverse we are and how we collaborate to create innovative solutions. Showcasing this very energy of Espressif, our next speakers are Radu Rentra from Romania, and with this occasion I salute my Romanian heritage, and Brian Ignacio from Dominican Republic but living in Shanghai.
Radu and Brian are part of Espressif's IDE team, and they're going to talk about all the debug features we have on Espressif's VS Code extension. They're also going to explore how you can add ESP-IDF tests using the testing lab of Visual Studio Code. Radu and Brian, the stage is yours.
Hello everyone, I'm your speaker, Brian Ignacio. Today we're going to cover a few of the new things we got for you so you can take a look. The outline is we're going to do an introduction. We're going to talk about the Eclipse CDT GDB debug adapter, the ESP-IDF unit testing on VS, and other features worth mentioning. About me, I am part of the IDE team. I work in ESP-IDF VS Code extension, ESP-IDF web extension, ESP-tool.js for flashing and monitor from the browser, and the web IDE using Eclipse Thea. I like cooking, I like coffee, and talking about technology and AI in general. This introduction about the new features. The ESP-IDF VS Code latest improvements. We have many features. Some key features are the Eclipse CDT GDB debug adapter, the ESP-IDF unit testing from VS Code unit testing UI, the ESP-IDF version switcher, code navigation without fully building, and other features. You can take a look at our VS Code ESP-IDF extension for VS Code in GitHub repository. You can check the changelog for any other additional features. First, let's talk about the Eclipse CDT GDB debug adapter. It's a new debug adapter to improve the debugging experience. But what is a debug adapter? VS Code implements a generic, it means language agnostic, debugger UI that is based on an abstract protocol. It's a protocol that was implemented to communicate with different debug backends. So a debugger typically uses their own long-established protocol. So we will need an adapter to communicate between a debugger UI and the traditional debugger. This adapter is a standalone process with its own protocol. It is defined in the Microsoft Debug Adapter Protocol. You can see the URL in the slides. Both the debug adapter and the abstract protocol is implemented by independent contributors. So many people can write their own debug adapter to implement different debuggers for the VS Code. In search for a better solution of our own for ESP-IDF projects, we choose the Eclipse CDT GDB adapter made by the Eclipse CDT GDB Cloud, Eclipse CDT Cloud team, and we made some changes. But the Eclipse CDT Cloud team adapter, it was written in TypeScript and is using a serial port npm package, and this allows us to provide some faster communication than our previous debug adapter implemented in Python. Another feature we implemented is the ESP-IDF unit testing in the VS Code UI by leveraging PyTest embedded and Unity in VS Code. So first, little bit about ESP32 unit testing. When you are developing an application using ESP-IDF and you are considering adding unit testing to your component functions, the extension allows you to discover unit tests already written in your project and be able to execute them on your real hardware target using Unity and the unit testing UI from VS Code. You can take a look at the unit testing in Espressif documentation in the link in the slides. So how do we do the auto detection? So this extension basically explores your current project workspace folder, so it follows the convention as described in the previous documentation. We will try to find all test cases files that follow the test_name.c blob pattern. And each test is rendered in the UI that is rendered as a test case as described in the presentation. You can see test case, the test name, and the module name. So we do a regex matching this pattern. In the background, we run PyTest embedded. It's a module written in Python that we written to execute PyTest for our ESP-IDF projects. And it allows you to run tests on the real device. So what we do is create a Unity app in your same project. This Unity app is basically a Unity menu that loads all your tests that we found in your device. So we will build this Unity app, we will flash it, and then we will use PyTest embedded to run this test. You can take a look at the PyTest embedded documentation in the slides. Other features worth mentioning, the ESP-IDF version switcher. Whenever you install an ESP-IDF version using the ESP-IDF configure ESP-IDF extension command, the installations are safe in a global state in the extension in your VS Code configuration. You can now use the ESP-IDF select current ESP-IDF version to set the ESP-IDF version you want for the current project from the list of versions you have installed before. You can see this command also in the status bar rendered as ESP-IDF version and the number version. And in the slides, you can see the drop-down with all the IDF versions that you can choose from based on your setup. Now you can enable the code navigation without fully project building. One of the key features of an IDE is code navigation. While working on your project, you usually want to benefit from such common language features, such as syntax highlight, code completion, go to definition, declaration, and etc. For C and C++ language support, there are many extensions you can use, such as Microsoft C, C++ extension, or the CLangD. Most of these extensions rely on a compiles command JSON. This is a JSON compilation database, which is an array of command objects where each command specifies a translation unit used to compile in the project name. This basically means where to find the definition of a function, object, etc. Now, you can generate such file, a compiles command JSON, for code navigation without fully building your project just by running this command, ESP-IDF IDF-PY reconfigure task, which basically will run the first step of building, which is just reconfigure. If for any reason you don't want to fully build the project, but you still want to use code navigation, this command can help you to generate the file for enabling code navigation and syntax highlight and such other language features. Now, let's take a look at some example code. So here I have two projects. First, let's execute this project. This is the test project. Here you see I have just an example unit test. This is from our VS Code test. This is from the ESP-IDF examples unit test, which has a component that has some unit tests defined. So this component has our project has a component called testable that includes a test, and this test has 3 test cases. So you can see that in this project we have open, we go to this testing tab, and the VS Code will find this test. And if you run this test, there's going to happen that you're going to see 2 things that are going to be executed. First, the PyTest will be installed if it's not installed in your Python packages in your virtual environment. Or you can use this command, install ESP-IDF PyTest requirements, and it will build and flash the unit test app for testing, as we discussed before. So here now, what you need to do after this happens, you just need to press play here. This will execute the test. You see that PyTest is getting executed. We skip the building and flashing to save some time, but basically it will build and flash the Unity app application before, if it's not in Flash already, and you see that the test get executed, and you can see some for each of the tests here. And the terminal shows you the execution for each of the tests. As you see, each test can be run individually, or you can run the whole per file test. This is for the unit test cases. These tests can be auto-detected. You can clear the results. And yeah, that's pretty much it for the unit testing. You can see here the button for the select current IDF version. If I click here, you can see that the list of IDF version, and if I select one or another, this will update here, and it will update the version on your system. Okay, now let's take a look at some example code. So here I have just the Blink example, and this Blink example is going to use the new launch JSON configuration. So now we have this new configuration called GDB target. This is the one we implement for this new debug adapter. And now basically you want to build and you want to flash the project. I already built, but let me flash this project. Okay, now that I flash the project, I'm gonna close here, and then I'll start a debug session. So starting a debug session can be very simple. You just need to press F5. You can see that the output will show you some output from OpenOCD. And in the debug console, you can see the debug console with the several things. You can see the threads getting generated and all the communication between GDB and the VS Code. If you want to run some commands, you can do some like this, threads, for example, and this will run some GDB commands. You just need to put this sign first. This is for the console. Now you can do some simple operations like a step, like continue. You can run these commands: a step over, a step into, etc. You can see some of the things here. You can see the step into, but we did the step into in the wrong location. Sorry about that. But here you can see some the lines being executed and things being go forward. So now let me talk a little bit about the UI. Here, for example, I have just an array, and you can see this in memory. If you click this sign, for example, you can see the binary data. And the binary data, you can see the decoded text is the same matching as I have here. Hello, world Brian. Hello, world Brian. You can also see the registers here. You can watch specific variables. There is also this implementation of peripheral viewer, where you can see the values of a specific output for the GPIOs. So for an example, when you link the LED or something, you can see that there's some things get updated. To enable this ESP-IDF peripheral viewer, you need to add the SVD file that you can find in our Espressif GitHub repository. And then you just need to save a setting here, SVD file path, and then you pass the SVD file. If you define that, you can see in the debug, you can see here, you can see the peripheral viewer. You can also see the call stack, and you can switch between tasks. You can switch different tasks, and you can switch between different things. Here, you can see some error, something like this. And yeah, and this is the basic. This is basic debugging. But now also you can see here that I have an error that it will panic. So this is the reason why we don't allow the thing to fully continue. So now, if you wanna capture these specific things, you can do something like you can run a monitor for core dump and GDB stop. So if you start this, you will start a debug session when there is an exception occur. So you see that the monitor started, and when the exception was rendered in the monitor, you see that there is an output that there is an error core and guru meditation error in the IDF monitor. But this will trigger a socket event, and with this command, the launch IDF monitor for core dump GDB stop mode, it will listen to this event and it will trigger a debug session. And you can see that this will capture here the exception that has occurred. And then you can execute tasks that you will do in core dump and GDB stop modes. Please take a look about IDF documentation regarding these debugging modes. Yep, and that's all from my side. Thank you for watching. I hope you like these features, and if you have any questions or doubts, please contact us through GitHub repository or our official communication media. Thank you very much.
Hi guys, today I will show you the new feature which is called Hints Viewer for the VS Code extension. A little bit about myself. I work as a developer for the project of ESP-IDF VS Code extension. In the free time, I like to watch and practice Brazilian Jiu-Jitsu, and also I like to tinker a bit with programming on different domains, such as game development or web development. So let's jump straight into it. I'm going to present you, as I said, the Hints Viewer. This is the first version. Currently, there are two main functionalities of the Hints Viewer. One is hovering over an error, and also there is a bottom panel which display the errors and the hints, and it gets automatically updated based on the text editor's errors. It can also be used to search for specific hints manually. So let me jump straight into VS Code. And here I have opened a Blink example. And what I will do now is that introduce this include with this library, which is deprecated because it has been changed. So now if I would have to save this file and build the project, I will receive an error indicating exactly this error. So now if I hover over the error, I can see here that I get a hint telling me what I should do. This hint comes from the hints.yaml file inside the ESP-IDF. So yeah, we are trying to keep some of the errors that we know that might appear and provide some hints for them. So yeah, this is the first functionality. The second one is this bottom panel here, which you can see it gets updated with the error from the text editor. Also, from inside here, you can search error by yourself using a string. So in this example, let's search for CMake errors. And right now, yeah, as I said, it looks inside the hints YAML file, and all the errors that have CMake error inside them are getting displayed here. So let's fix the error as it was described when I built it. So I will just update this library here. And as you can see, now the project doesn't have any other errors. So as I said, this is the first version of the hints viewer. We're planning to improve it. And one of the improvements would be to target only the errors that are coming from our extensions. So this will help with searching algorithm. So yeah, this is it. I hope you will use this feature and provide us feedback on ways on how we can take this a step further. Yeah. So that will be it from me. Thank you guys for watching.
Thank you guys for that engaging talk about VS Code extensions.
Sudeep, I've come to know that GUI programming, but also recruitment, can be really, really difficult.
Oh, I agree, Annie. GUI programming can be tough, but there's a powerful approach which can simplify things. It's called declarative programming. And our next speaker is going to tell us all about it and how it can simplify GUI design.
Right, next up we have Olivier Goffard, the co-founder of Slint, to show us how to build GUI on Espressif devices using C++ and Rust. Over to you, Olivier.
Welcome to this presentation about Slint. So I'm Olivier Goffard. I'm one of the co-founder of Slint. Slint is a UI framework. So this is a native UI framework as opposed to running in a browser. So it's not using a browser. And it's meant to be used for desktop, mobile, and embedded applications. In a nutshell, Slint is made out of a markup language. So this means that you describe the UI in this markup language, describing all the elements. And then this markup language is compiled to C++ or Rust, or it can also be interpreted. And the UI is made in this markup language, but all the logic, the programming is made in an actual programming language, for example, Rust, C++, JavaScript, or Python. The runtime Slint library is actually written in Rust. Behind the scene, it's Rust, but it can be compiled to just a static binary. So we have API from different programming language, and the developer don't have to know it's made with Rust. They interact with API just like if it was a normal C++ or JavaScript library. Regarding the license, Slint is open source. It's GPL. It's developed on GitHub. You can fill issues on GitHub. You can submit PR. The GPL means that you need to share the source code of your application. So for that, we have, if you don't want that, we have different licenses. There is a royalty-free license for desktop users and mobile users, but for embedded, there is a paid license. So check out our website; it has the pricing. Let's get quickly to make a demo. So in this demo, we're gonna use ESP-IDF. So we have a component, we have a Slint component in the ESP-IDF repository. The README explain how to get started. So the first thing you have to do is to we increase a bit the font. The first thing you have to do is to follow the step to get the Espressif SDK on your machine. So you can just follow the website from the Espressif website to get the ESP-IDF installed. Since we are also going to compile Slint from source, you must have the Rust compiler installed for this to work. You just follow the step to install the Rust compiler. There is a little tricky thing, is that since we're going to work with targets such as Extensor, this is not yet, as of now, in upstream Rust, so you need to install it from the Espressif Rust project. They explain how to install all the tools you need. Then we're going to follow this thing. Just to create a project, we use the Espressif ESP-IDF tool to create a project and set the target and everything as it stands. So what we have here is an Espressif box. So we have the box 3. So in this case, this instruction was for the box 1. So here we use ASP box 3. We add also the Slint dependency. So I'm now going to go directly to the editor. So we have added a Rust toolchain file just to specify that we need to use the Espressif compiler instead of anything else. That's because we use the Extensor, so we need to use this compiler. There is a CMake list that just tells that we're going to compile this network settings.cpp, and we also require the Slint dependency, which is the Slint dependency is one of the dependency in the IDF component. And there is a special makefile CMake lists command here to tell CMake to compile this file to C++, and then it's going to be included. So I can already start running this thing. So I can flash it, and while it's running, I will go back to the code, and I will actually resist this a bit so you can see, and show the Slint code. And this is basically already flashed. So now we can see that I have my this little interface was flashed just now. This comes from this file, this Slint file, which is the markup file, which has this about Slint and this text. And what we have here, we have a little show preview button. This comes from one of the extensions that we have. So in VS Code, you can search for the Slint extension and install the Slint extension. Then we have a show preview button that appears, and this open a preview window. I can resize a bit things so I can have everything on the screen. Yeah. This preview window, so if I type things, it updates in real time in the preview, and I can also enter the edit mode. Just trying to resize. So from this edit mode, I can even drag and drop things. So for example, I could drag a spin box or a switch. So I'm just gonna put a switch and I can move things around. So I'm gonna move this text here. And what I'm gonna do actually is a small example, which is like a network configuration tool. So network settings. I don't need this. I delete it. I will change the layout alignment to be on start. I will also remove this pin box, this switch, and as you see, when I do changes there, it also change in the source code. So here I'm gonna rename this switch to say enable Wi-Fi, and the text is changed there. For this one, I will also change and say, for example, enable Bluetooth, and it changes. So I'm gonna quit this edit mode. I'm gonna now be in edit mode because I will add more things in the code directly. So one thing I would like to do is to list networks. So I would like to be able to select one of the Wi-Fi network, for example. So I will have a struct network info. I will declare this struct that it has a SSID, which is a string, and strength. Which is an integer from 0 to 100, for example. And then I can add a property. It's an input property because we're going to set it from the C++ code later. And this is a list of network info. I'll call it networks. Then I could put it here under there. I would say I will create a for loop for the net in networks. And for now, just a text whose text is SSID. Of course, there is not yet any network. I will just add some dummy data here. So SSID hello, and another one SSID world. Need to add. So there I can see my network here. I'll just add some level for completeness, strength, and strength. I'm gonna make it a bit more pretty now. So instead of putting it right here, I will create a new component called network details. Network details. And this component will have also a property of the same type. So I'll just copy this. And I'm gonna put a rectangle, and I'm gonna put a vertical layout with this thing here. Instead, I will call the network details. Network details with the network property is going to be the root networks. I'm going to format the file. I can make it a bit more pretty by changing the background of this rectangle. So I can access the palette. The palette is going to be imported from std widget. Here my IDE, the extension auto-completed, so it added even the palette there, so I can use it. And I have a controls background, which is a bit different background. I'm going to add a bit of padding, 2 pixels, and some spacing, 5 pixels. And I want also to visualize the levels here. So I'm just going to, instead of a text, I'm going to put this in a horizontal layout with the text in it. And here I'm going to have a rectangle to display the different levels. This rectangle will have, let's make it square, so its width will be the same as its height. And backgrounds, for example, we could have, let's make it a gradient, a linear gradient that goes, for example, from green to black. And we're gonna put this black level at the strength of the network. So strength divided by 100, so that the gradient is bigger for network that have a big strength or not. This is maybe we can change a bit. We can also use a transparent after the black, and if we do the same, we can have like different level. Black was maybe not the best color, so we can change that to something like this, or we can use this feature to take something a bit more dark. Something like this. So that's all. And it was actually nicer with a lighter color here. Maybe not so light. Anyway, you can like this design and preview in real time. And we can as well go back here to our terminal and compile again and flash again to the device to have the preview in the device. I need to save. Restart. So while this is working, we can try to also, what we want to hide this when the Wi-Fi is disabled. So we'll have a property shown, and when the thing is not shown, we will have a height. So let's change our height. So when it's going to be shown, then it's like this ternary operator. We're going to use the preferred size preferred height based on the layout. Otherwise, we'll use 0. And we're going to click this. So now it's hidden. Let's make it shown when the switch is on. So let's give this Wi-Fi a name, Wi-Fi switch, and shown when the Wi-Fi switch is checked. Yep, so we have already that. And in the meantime, we have our little demo is already running on the, so I'm not really seeing what I'm doing here, but yeah, and it was before I did this enabling. What I can do is to make it a bit more animated. So I can do animate height for a duration of, say, 300 milliseconds. And so this already gives some animation. And I can also make it a bit more prettier with an easing curve. So for example, ease in. So now we have an animation. I can save this and compile this again. Of course, I want the thing to come from the C++, so I will change that. I will add here a callback, Wi-Fi enabled with a Boolean. And when the switch is toggled, I create a callback for when the switch is toggled, and I will call my root callback self.enabled. So now it's flashing. So I have again the thing now with an animation when we load the network. Okay, now let's write the C++ code for our application. So for that, I'm gonna set that when you click on this, when you enable this thing, we are gonna use a task in the background to query the Wi-Fi. I have here some code already, some sample code. I will just copy paste this. So this is gonna create two tasks, one network task and one UI task. The UI task is actually this one, UI task, which runs lint. So it sets everything, run, and we want that UI. So I create a callback called with Wi-Fi enabled. So I'm saying when on Wi-Fi enabled, then I can use a lambda here. When it's enabled, then what we're gonna do is to wake up our network task. There is some code for this here that I've copied. First things we will store this UI instead of being on this on the stack here. We will put it in a static. So it's going to be a slint component handle of the main window. The main window is the name of our main component in appWindow.slint, or it's called appWindow actually. AppWindow. It's called UI. And then we are just gonna do like this. Then we need to dereference it, UI, and we can UI set network. So we're gonna just clear the network when pressing this button. Clear the networks and notify the network task. I need to move this a bit up. This network task, what it does currently, it just so it simulates. I'm not gonna write the actual code to read the list of Wi-Fi network. I will just hard code them. So it just here wait 3 seconds after being waken up, as if it was searching for the network, and then I'm gonna create a vector with a network info. So the network info was declared in slint, and the slint generated code, which we include there, contained the struct network info. net, and then I can initialize it with network info with a SSID, for example, home network, and a strength. Did I spell that correctly? Yes. Strength of, just put some number. That was one. Another one, guest network. Less. Okay, so now I have this vector of network. I can just pass that to Slint. I will call Slint invoke from event loop. So this function basically is going to take a lambda and is going to run this lambda on the other task, on the main task, on the event loop. I can move the nets there so that I can call my UI, which at this point I can use it because I'm in the UI thread, and I will say set networks, and I cannot just put the vector. I need to move that into a Slint model. So this one is need to be in a share pointer. Make shared of a vector model of network info. Okay, I think that should be it. Let's try that. Let's see how many errors there is. So this will basically, when you switch the switch, it will tell Slint to, no, it will tell the network task to do this work. Anyway, there was some errors. Let's see what was that. I seem to have forgotten a semicolon. Let's try again. No errors. Network info. Is it called network info? Yes, network info. So what's this error? No. Expected. Yes. I'm I got a bit confused between languages here. This is C++, so it needs to use this syntax. Okay, recompile. And now we're almost there. Our UI task should have just one pointer, not a double pointer. And okay, it's flashing. And we have now our UI. I can try to, oops, not easy to show the camera, to switch somehow. So basically, when we press, it waits 3 seconds, and then it shows the network. So that was it for my little demo in C++. If you want to use Rust, it's basically the same concept here. If you want to use Rust, all you have to do, I have an example in Rust. I will close the previous example. So this is again just the template that I'm opening. I have done nothing with that yet. I'm gonna copy over the code from previously, and this is Rust. In Rust, it's the principle is that you just call slint and slint build. We have a build script that runs through the build.rs. So the build.rs, you just tell him to compile your slint files, and then the main rs we can include slint, and here we have our little network settings, which is built from Rust. This is not yet running on a microcontrollers. To run it on a microcontrollers, we have some docs. You would not want to, so it's in our documentation, on our slint documentation. We have a link to the microcontroller documentation, and you just can basically implement a platform. If we already have a platform for this, you would need to use ESP-HAL. So this is basically bare metal to show how to develop this in bare metal. So I am out of time, I think, so I will end the talk here. Thank you.
Hello, and we are back for another Q&A session. For this session, I'd like to invite Olivier to join us. Hi, Olivier. How are you today?
Hi, I'm good, thank you.
Yeah, so it's a pleasure to have you here. And I hope all the audience are really enjoying your talk. We have a couple of comments from Rudy. So I'd like to thank you, Rudy, for your very nice comments. I will read it here, and then you can comment as well, Olivia. So first it looks like it will be very easy to use, very understandable from the structure as well. I like how it can be built up in a very special differentiated way, UI and code, and never lose track of the context. And we have another one here. It's like going to a UI department. It's like going to a UI department and create the UI order, and at the same time consulting between the code and having the result visible right away. Great. So those comments came from Rudy.
Okay, thank you very much. So much praise. That's good. Yes, I don't have.
Yeah, so it's nice to see like the nice feedback from the community. I know maybe EasyLint could be I know a new solution for some of our viewers. So we are letting them know to how they can easily develop a GUI application very easily with EasyLint and Espressif chips. We have as well one question here. Would be nice to have quick fix options for those easily fixed errors.
Yeah, that's true. So we already have some quick fix. So I do not remember at what point this comment came and which error in particular this was. But we do have some quick fix, for example, to add imports when they don't, or things like that. So if there is any particular fix that needs a quick fix, we can improve that. Fill an issue for something you have IDs for quick fix.
I see.
Yeah.
And I'd like to know if you have any future plans for EasyLint or anything you can share, because we recorded this talk I'd say like 4 weeks ago. So is there anything you'd like to share with the audience?
So we're working now on the new release, and as far as Espressif is concerned, one of the change would be that we're going to have pre-compiled binaries. So EasyLint itself was developed in Rust, and when built as a C++, as part of a C++ application, so it's a static library, and it, as of today, it still requires you to have the Rust compiler just to compile the static library. But in the next version, we're going to have binaries so that you don't even have to have the Rust compiler. It will download the static library and build on top of this. That's one of the change in the next version. Otherwise, to stay connected, all our development happen in the open source in GitHub, so we don't have any secrets really. This is
All right. And what's the best way for the audience or anyone that is interested in EasyLint to get in touch with you guys?
So just visit our website or GitHub repository. We have a chat on Mattermost, emails, the typical channel, but the easier I would think is GitHub discussion, GitHub issues.
All right. So Olivier, thank you so much for your talk, for being here, answering the questions.
You're welcome.
Yeah, so now we can go back to the studio.
Thank you, Olivier, for that brilliant exploration of building GUI with EasyLint. So deep. Now that we have sorted our GUI, let's talk something just as critical, security.
Absolutely, Annie. Up next, we have Jim Scarletta, who is going to preview cryptography with wolfSSL. Jim will show us how to get wolfSSL working across targets such as ESP32 and ESP8266, but also he will show us how to use it on ESP-IDF, Arduino, Platform IO, and Visual Studio.
The talk is for anyone who wants to take security seriously for their projects. Let's hand it over to Jim Scarletta.
Hello, everyone. Thank you so much for taking the time to listen to my presentation on getting started with wolfSSL on the ESP32. Today, we're going to be discussing not only wolfSSL, but taking a look at a TLS example. So first, a little about me. I've always been passionate about embedded electronics. My first embedded project, I designed a 6502-based industrial controller for my senior project at Cal Poly. Today, I'm focused on embedded cryptography on the ESP32 devices at wolfSSL. Some of you may also know me by GoJimmyPie on social media. And so today we'll have a brief introduction to wolfSSL, how to get started, why choose wolfSSL, and where to find it. At the end, we'll have some time to answer some questions. Go ahead and ask the questions in chat as we go along. And so first, what is wolfSSL? Well, wolfSSL is a set of lightweight, high-performance, secure cryptographic libraries and applications related to open source internet security. It's all found on GitHub. So here are some of the many places where wolfSSL is already used. It's used to secure devices and communications in many different industries. It runs on nearly any device, from the tiniest embedded controller to massive cloud, VPN, and other computer systems. So as I mentioned, wolfSSL, it's a software library. It's designed to help developers implement secure communication in their applications. Think of it as a toolkit that helps apps and devices talk to each other safely over the internet or over other networks, ensuring that the data sent between them remains private and unaltered. At the core is wolfcrypt. This wolfcrypt library contains all the cryptographic algorithms that can be used by your applications and by the various other wolfSSL products on the ESP32 or other platforms. And so, although wolfcrypt libraries support nearly all possible protocols and algorithms, users of the ESP32 are likely interested in a tiny, secure connection with TLS to talk to some other computer, or perhaps some cloud provider with data acquired by ESP32. One of the smallest footprints I've configured is on this Arduino Nano 33. I was able to get TLS working with less than 24K of RAM out of 32K total. And so, of course, you want standard TLS 1.3. That's ready to go. TLS 1.3 is the latest standard. No extra steps are needed, but perhaps you want to add post-quantum. That's available too. It's just a configuration setting. And later on, we'll talk much more about all the different configuration settings. The wolfSSL TLS 1.3 has been around much longer than Embed TLS, and it's considerably more robust. And so perhaps you're doing business in China. We support the SM ciphers, if you haven't heard of them. They're a suite of cryptographic algorithms that are widely used in China. wolfSSL added SM cipher support in 2023, and the core wolfSSL library can support the SM ciphers with the install script you see on the screen. So the SM ciphers are in the wolfSM repository, and you just run an install script pointed at your wolfSSL directory, make some configuration changes, and you're ready to go. And so how to get started? Well, like a lot of things, that depends. What are your requirements? Later on, we'll talk more about wolfSSL, but right now, I'd like to jump in and get started with some examples. I personally find seeing examples as a great way to get started. You can use wolfSSL on nearly any editor, nearly any platform. There are many options depending on your requirements. We'll start with what I think is the easiest method. So you can find the examples out on GitHub in the wolfSSL/wolfSSL repository. There's an IDE directory with many different IDEs. Inside there, you'll find the Espressif directory and the ESP-IDF, and under there are the examples you see on the screen here. So the core examples include a benchmark for performance check, just so how fast are the various algorithms, and you can fine-tune performance in the user settings. There's a test application, the wolfSSL_test is to make sure that all the algorithms are returning results as expected. There are also client and server TLS examples. If you want a no-fluff, bare-bones project, just getting started from scratch that includes compiling in wolfSSL, it's just a hello world, it prints a version. The one at the top there is called the template, and it's a great way to get started from just nothing and get going. And so when you use wolfSSL, you can also use wolfSSL as a component. We'll talk more about that later on. And so the bare bones template uses wolfSSL as a component. And here we see it as a local component in the project. And later on, we'll talk more about the other ways you can use wolfSSL. But this one specifically is a local component in your project, you'll see that it's in the components directory there. So all the examples on GitHub are ready to compile in place. Later on, we'll talk about different alternatives for installing wolfSSL, but here, the examples use the source code located in the repository. The CMake file, it actually searches parent directories looking for the source of wolfSSL. And in this case, it's just a few directories up. So you won't actually find the source code for wolfSSL in the examples. And you see the source files there, you see the little / slashes going up a few directories as to where the CMake file found it. Most importantly, the user settings are in the components wolfSSL directory in a file called user settings. And later on, we'll talk much more about the user settings, but that's probably the most important file for wolfSSL and setting the different options and configurations. And so first, we'll get started with an example here. And this is a sample TLS client. And you can see here that the first thing you do is you run the wolfSSL init. That gets all of the wolfSSL environment set up and ready to go. And a couple of lines down there, you see us opening your basic TCP socket. So next, you pick a TLS version, and you'll see some of the ones that are commented out there for if you want only TLS 1.2, only TLS 1.3. You can choose which ones you want to use here. Here you see a little bit of flexibility in which TLS version will be allowed upon a connection. There's an option here to ignore a peer check. But in this case, you'll see where the do peer check is set to true or 1. So a couple of lines down, we'll actually do a certificate compare with the peer. And so you see the set verify none is not being used here. So instead, a little farther down in the code, you'll see the steps to verify the peer with loading the client certificates. So there's a wolfSSL function here that loads the certificates. And these certificates are located, if you look at the user settings, it includes information on where those certificates actually are located. You can, of course, plug in your own certificates. The next step down is we load the certificate authority. This is the public key certificate. This is the digital document that certifies the ownership of a public key, typically issued by a certificate authority. wolfSSL does have a sample also in the user settings. You can take a look at that. This is used to verify, the public key is used to verify the identity of a server or client, so when the connection is made. Here we see using wolfSSL to load the private key. So there's also a private key provided by wolfSSL in the examples. This is the secret key used in cryptographic operations. When paired with the public key, it's used to decrypt the data and used to create digital signatures. And so you see here some little error checking afterwards to make sure that everything was successful. So previously we talked about the peer verification. And so here you'll see the wolfSSL verify peer option. I hovered over the function there so we can see the parameters. So that last 0 is for a callback, and we're not setting a callback, but we are doing the peer verification here. And so next, we open a secure socket connection. We're going to open a TLS connection, and you see we new up a CTX object, and that's the wolfSSL context object. And you see if you have debug turned on, it'll also show you what ciphers are available. So it's grayed out here because I don't have debugging turned on, but it's a simple matter of going to your user settings and defining the debug wolfSSL and then turning debugging on. This example also has the SM ciphers disabled by default. But again, you can install the SM ciphers, go to your user settings, turn it on. The default user settings does include an example of how to turn on the Chinese, the Shengmi ciphers. And you'll see that you needed an explicit step here to set the key share. So once you've gone through that, all you need to do is attach wolfSSL to the TCP socket and connect. And so once you have the connection going, it's a simple matter of writing and reading data. So here you see an example of doing a wolfSSL write to the secure connection. So we have a buffer of len bytes long, and it'll send that out. And of course, to read data back, there's a wolfSSL read. It'll read data into your buffer there. And so here's an example. So I have the wolfSSL client that we were just looking at in PuTTY on the lower part of the screen there and in the COM port. And I have a client, sorry, the client is in PuTTY, and I have the server listening in WSL on Windows in the top part of the screen there. So I have those two overlaying on top of each other. And in this case, you'll also see that we have post-quantum. So the command line options allow you to enable post-quantum from command line there. And you'll see that we did a post-quantum key exchange with Kyber. This key exchange with the ESP32 was TLS version 1.3. You see the cipher suite that was involved. So the client, the ESP32 client, says hello message, and you see down below that the client, the server then responds with a I hear you for shizzle, and that's a typical common response for all the examples in wolfSSL. So it's important to note that all the wolfSSL TLS examples, they're all configured to be on port 11111. That's 5 ones. And so in my WSL example here, I needed to make sure that I had that port open on the Windows firewall. So when practicing with these examples, that's super important to make sure that your firewall is letting the packets go through. Wireshark can be super helpful in examining to make sure that, like, you see what's going on, but can't emphasize enough the importance of making sure that the firewall is allowing the port you're talking on and that you're talking on the port that you think you're talking on. So beyond the examples, we're going to talk more about the user settings in the CMake file. We mentioned before the user settings. This is where you customize wolfSSL for your specific use case. There are many, many different features to turn on and off. You probably don't want to turn on everything because it's big and bloated code. So you typically only want to turn on the features that you want. You can optimize it for performance or for size. It's all about the specific use case and what it is you want to configure. The other thing to look at, not as important, but you should probably be aware of it. It's the CMake list for wolfSSL. It's how the component is defined. And there's also an option in there to force a specific location of the source code if you want. So there's a variety of different ways to set the source code location. But it's important to know that the wolfSSL component in the examples, the source code is not there. It's shared source code in the repository. And as long as wolfSSL is in a parent directory of your project, you can go ahead and just use the default there. If you have a project that doesn't have wolfSSL in a parent directory, you can manually set it, or later on we'll also talk about managed components that kind of frees up that whole problem there of finding where the source code is. So here you see an example of that. It's called wolfSSL root, and it's near the top of the CMake file. You can just hard code a specific location if you want. We're also working on some features in a GitHub repository related to Espressif. We'll talk about that a little bit more later on. That's super exciting. There's an alternative way that we'll be adding a feature to set an alternate location for wolfSSL. But right now, it's the wolfSSL root is where the source code is located, and it's set automatically again if it's in one of the parent directories, or you can hard code it to a specific directory of your choosing. So if I were to present only one slide to talk about getting started with wolfSSL, it might be this one. For wolfSSL, it's all about the proper use of the settings, the user settings. And here we see an example. You need to make sure that globally defined, there's a macro called wolfSSL_user_settings. That tells the environment that you're using wolfSSL. You see that we're including the wolfSSL wolfcrypt settings.h. It's super important that everywhere you use wolfSSL, any of the libraries, that the settings.h is included before any other file. Here I have an additional check just to make sure that the ESP-IDF has been properly detected. If not, unpredictable things could happen, but as long as you have that previous macro we talked about, we have that defined, and you include the settings.h, everything should be okay. You might want to also notice that I'm not explicitly including the user settings file. Okay, so the only thing you need to do is make sure you include settings.h before any other wolfSSL include files, and do not explicitly include the user settings. So the settings.h automatically pulls in the user settings and defines things as appropriate. I have another example here just in case you wanted to use any of the ESP32 cryptographic functions directly. It's in the ESP32-crypt header file, and you notice how it's below the settings.h, right? Again, super important, include the settings.h before any other wolfSSL include file, and do not include the user settings.h. And the user settings, that's where everything is configured for wolfSSL. And so next, continue on how to get started. If you want a super easy way to just add wolfSSL to your existing project, you went to the components.espressif.com. It's the ESP registry, and there are examples there. And I have a screen shown on the screen here of how you can just copy that one line, and it'll add an entire component for wolfSSL to your project. And in this case, it actually does install when you build your project. It actually does include all the source code. It downloads it from the ESP registry, in contrast to what we previously talked about of having source code located someplace else. So of course, as a managed component, you're probably not going to be wanting to make changes to that and contribute to upstream with GitHub. But this makes it super easy just to add wolfSSL to a project and get started. So if you don't have an existing project, but you still want to try managed components, there are existing examples. And so you'll see here when you visit the website on the screen there, and really you can just go to, just search for Espressif ESP registry, and you can find the managed component registry. Just search for wolfSSL, and the last time I looked, it's really cool that wolfSSL is even listed on the home page. So you can just go there. Off on the right-hand side, on the right-hand side, there are some examples. And you can just click on that tab, and you'll see with just a few lines, you can get started. So you see, first I'm setting up the typical environment with export.sh. There's another icon that'll be on the screen that'll allow you to connect that second line, copy that to your clipboard, and you'll see that there's a idf.py create project from example. That'll create, in this case, the wolfSSL test. It'll create the entire application, including the managed component in a directory called wolfSSL test. All you do is you cd into that directory, and you build, flash, and monitor, and it should get going immediately for you. So yeah, the only catch there is make sure you probably want to specify a COM port. It'll look for the first COM port available. So if you have several, you might want to add the -p for the port, the COM port. So in summary, we talked about some of the different ways to get started. We have the ESP registry. It's by far the easiest way to get started with wolfSSL. You can also install wolfSSL either in your project, in the components directory as a local project, so components/wolfSSL, or you can install wolfSSL as part of the IDF. So you go to your install of the Espressif ESP-IDF, you'll find the components directory there, and you can copy or install wolfSSL there. So again, we talked about the CMake file for share code. That's one of the ways that you can point to wolfSSL. Oh, and the other thing is, yeah, we have Visual GDB project. So if you happen to use the Visual GDB extension, which is what I do all of my development with, the extension for Visual Studio, there's a Visual GDB directory. All you need to do is open up one of those projects and you're ready to go. So one of the more significant announcements earlier this year relates to the use of wolfSSL in the ESP-IDF. So in the previous slide, we talked about possibly manually installing wolfSSL as a component there. But recently, if you look at this issue out there, and it's in the Espressif repository and the ESP-IDF repository, issue 13966, it's basically the core issue for tracking all the improvements for wolfSSL integration with the ESP-IDF. And one of the first comments you'll see down there is it's been regarding licensing issues, and Ivan was super helpful in pointing out the ability to use wolfSSL as a local component installed in your application, but for the ESP-IDF to actually see that. And we're going to be adding support for everything in the ESP-IDF so that you can completely remove embed TLS and use the commercial grade wolfSSL code instead. So previously we were talking about the configuration. Here's a summary of kind of where all the configuration happens. I have the expression there, with power comes complexity. There are many different settings. The user settings, by default, it has a good getting started, but there's documentation online for finding out where all the other user settings, what's possible. So you first start with the IDF menu config. It generates the SDK config file. You don't want to edit that manually because it gets auto-generated. All of the wolfSSL settings are in the user settings.h. Just for reference here, that you can see what goes on in the ESP32 crypt.h file. It's for reference. It's not meant for any changes to be made there. And finally, we talked about the settings.h. You can see where settings are adjusted there, but it's not recommended that you go into the settings.h and make any changes. The settings.h will typically change from release to release. We do accept pull requests, but for any project settings, you want to make sure that all of the settings that you make are in the user settings file in the components directory. So, and I also want to point out that the wolfSSL user settings applies to all wolfSSL products. So here you see some of the other related products. wolfSSL is a managed component. I also have wolfMQTT and wolfSSH as managed components. We have wolfTPM support for the ESP32. I don't yet have a managed component for that, but all those other products do not add a wolfSSL user settings file in the include directory there. There's only one user settings, and it's in the wolfSSL component. All of the other wolfSSL products will use the one user settings in the wolfSSL. So here's an example of what do you do with other components. Here I made a fun little project called SSH on a stick. It's the M5 stack, the M5 stick product from them. It's a Wi-Fi hotspot. You can SSH into that IP address, and you see here I have it connected to a UART. So this example is using wolfSSL and wolfSSH as essentially a Wi-Fi SSH to UART example. And I probably should point out, like, not only can wolfSSL do TLS over TCP, but we can do TLS over pretty much any transport, Bluetooth, etc. So there's another getting started video that I presented not long ago. It's available on YouTube. Has a little bit different content. There you can find some details on JTAG debugging, more information on using the Visual GDB extension with Visual Studio, and more. So now that we know what wolfSSL is, well, why would we want to choose it? Well, it's by far the best tested cryptographic library out there. It's certified, widely used throughout the industry. There's a lot of companion products. So we talked previously about some of the different products. So it's all a family of similar and related products. We have a lot of partners, a thriving community. A lot of people really enjoy using wolfSSL, and we'll talk a little bit more about that in the upcoming slides. Yeah, previously we talked about the different products. You see them again here. Why choose wolfSSL? Because, well, when you want to do MQTT or SSH, or maybe even want to just use the same wolfSSL libraries that you're familiar with all the different environments you see across the bottom there. We have wrappers for different environments, for C#, for Java, for Python. You see that wolfSSL is used with curl. And so why would you choose wolfSSL? Well, for an ESP32 user, probably the most compelling reason is the really tiny footprint. Additionally, we talked about certifications. So it's FIPS certified. So that means basically the NIST has gone in, and if you have a project and you want it certified that it does exactly what you say it does, there's a certification process available for that. There's also DO-178. That's a certification typically used in aviation. We have 7x24 support. It's dual licensed. So you just ask yourself, so how important is security? Is the library easy to use? Does it have all the features I want? So you look, you compare wolfSSL to embed TLS. You see we have really consistent attention to open issues, much lower volume, the things that stay open. On the topic of TLS, note that TLS 1.3 is the latest. So embed TLS 2 and 3, those are versions of their library, not the version of TLS. There's been some challenges recently with TLS. So curl, on the topic of curl, that's also a wolfSSL product in case you ever need commercial support. You can also use the libcurl option to generate some sample code to get started with curl. Another reason to use wolfSSL is we have an OpenSSL compatibility layer. So perhaps you already have a project using OpenSSL. It's super easy to get started with wolfSSL with our compatibility layer. So again, why choose? Well, it's a commercial grade serious software, open source, certified, up to 7x24 support. And so another reason to choose wolfSSL, you just ask yourself, are your cryptographic vulnerabilities handled promptly by professional dedicated staff engineers? So the wolfSSL vulnerabilities, when they're responsibly disclosed, they're typically fixed within 72 hours, and we will provide an update to our customers. And then shortly thereafter, we'll make an announcement that a vulnerability was discovered and fixed. We have dedicated engineers. You can get on the phone, talk directly to an engineer, automated continuous testing. And so more features. Before you choose an encryption library, be sure to check out all the features and capabilities, not only what you need today, but what you might need tomorrow. Here you see some of the additional hashing and cipher functions, for instance, available with wolfSSL. Again, we have the SM ciphers we talked about, post-quantum, the OpenSSL API compatibility. So it's used in many different industries. We keep somewhat of a low profile. We don't advertise who all of our customers are. But wolfSSL is used in many more places than people realize. There's billions of secured connections. We have 1,000 OEM customers. We have many resale partners. Here are some of our partners you see on the screen here. You might recognize some of these names. Even more partners, agencies, and more. Microsoft uses wolfSSL. You can find them. So it's a dual license. The code is clean rooms. This has all been written by scratch. There's no external dependencies, no prior baggage. It's completely open source, GPL v2 license. If you want a commercial license, that's also available. So where can you find wolfSSL? Of course, wolfSSL.com. out on GitHub, wolfSSL, in the Espressif components directory, components.espressif.com. We have an Arduino library. We have examples for them in the IDE directory. So we know here getting started, you can just search for wolfSSL in the library. You can just go to the registry, search for wolfSSL. The ESP registry for managed components. You go out there, you search for wolfSSL. And that about wraps it up. Let me know if you have any questions. You can contact us at support.wolfssl.com as well. Check out all the docs out at wolfSSL. Appreciate you all listening. Thanks so much.
And here we are for another Q&A session. For this Q&A session, I would like to invite directly from California, Jim. How are you today, Jim?
Hey, hi, I'm doing well, thank you. It's warm here.
Yeah. It's warm here in Czechia as well, like 33 degrees, so it's pretty warm. So thank you for your talk, and as well, thank you for being here for answering some questions. We have 2 questions so far. So the first question is, what is the status of wolfSSL support in ESP-TLS?
Oh yeah, so I had mentioned there's an open GitHub issue regarding the improvements that we're making, and yeah, just recently there's been a new pull request adding more robust support of using wolfSSL in the ESP-TLS layer. So yeah, that's it's an open pull request right now. Have certificate bundle support, you know, where there's some prepackaged certificates. I believe it's fully functional and should be good to go pretty soon here. And it'll be in the next release. You know, there's a managed component, so it'll be included in the next release, or you can just go to GitHub and get it.
Oh, that's great to hear that. So there is one question we have here that basically most of people should have. So which is what are some common mistakes developers make when implementing SSL or /TLS using wolfSSL? And how can they be avoided?
Yeah, that's a really good question, actually. And speaking from experience, and I talked a little bit about it during the presentation, it's all about the user settings. It's about understanding what features are turned on and which ones are not. One of the common problems I see is setting up the user settings. Like it's super important that you include the user settings that's included automatically, by the way, as mentioned in the settings.h, and that it's super important that that's included before any other wolfSSL include files. So that it's super important that that's listed first at the top, because otherwise some of the options may or may not be turned on for a given source file, and things get really messy that way. So yeah, user settings. It's all about the user settings, really.
Yeah, usually it is.
You know, and understanding your target too. You know, I actually just yesterday I opened up an issue on the ESP-IDF site that, you know, the OpenSSL, no, sorry, not OpenSSL, the House My SSL website. Yeah, it doesn't do TLS 1.3 as good as we might think. So make sure you understand the target that you're trying to talk to, right? Wireshark is wonderful for seeing packets, and make sure you understand who it is you're talking to. I've seen problems where people are behind a CDN, you know, a content delivery network, and things sometimes work a little bit differently than you might expect, especially in an embedded environment with which certificates are needing to be used.
Well, so thank you for sharing your points. It's really nice to hear, and I hope like the audience will as well think it's very insightful.
Thank you.
We have one. So I don't see any other question here in the chat. We have one comment again from Rudy, which is Dean. Yeah, the lecture is very organized and has like a clear structure with a secure direction. Felt a lot of effort and passion. Very informative and great tips from master that I didn't know yet. Thank you. So
that's
nice
super kind.
feedback
Thank you
from
so
Rudy.
much. Yeah, that's awesome. Thank you. That's very kind.
Right. And Jim, what is the best way to get in touch with you?
Yeah, well, for questions for wolfSSL, support at wolfSSL so that everybody can see. I'm also GoJimmyPie. I'm on social media. GoJimmyPie at gmail.com or jim@wolfSSL.com. But for specific wolfSSL questions, kick off an email to support at wolfSSL.
All right, thank you. So again, thank you for your talk, for answering the question and being here for the DevCon. Thank you, Jim.
Oh yeah, thanks. I appreciate you having me. Thanks so much. It's been great.
And now we can go back to the studio.
Thank you, Pedro, and thank you, Jim, for enlightening us on wolfSSL and how we can use it on Espressif devices.
With that, we are at our last talk of the day, but you will want to stick around for this one. Sudeep, I know that we can really build really cool product, like a video doorbell with our Espressif chips. However, I know that also it takes quite a skill to stream audio in real time between devices and video as well.
Indeed, Annie, it is quite a challenge to stream audio and video real time between devices. You may need a framework like the WebRTC. And if you are also working with WebRTC, we have Tian Haibo introducing us to ESP WebRTC. It's an integrated WebRTC solutions for ESP chips. Tian Haibo is going to tell us about the benefits of ESP WebRTC, and he will also demonstrate it using ESP32P4 and a mobile phone. So let's welcome Tian Haibo.
Hi everyone, today I will introduce ESP WebRTC, a WebRTC realization on ESP32 service platform. First, let me introduce myself. My name is Tian Haibo. I work in Espressif Media Solution team, and my main job includes design and maintain media framework, media protocols, also develop some media solutions. My talk will include 4 parts. The first part, WebRTC basics. Then I will introduce ESP WebRTC. The third, I will compare ESP WebRTC with our ESP-IDF. Finally, I will also share some debug tips. Firstly, let me introduce WebRTC. WebRTC is a big protocol and it contains many RFC docs. Firstly, let me introduce some key terms about it. RTC, real-time communication. SDP, session description protocol. DTLS, diagram transport layer security. RTP, real-time transport protocol. RTCP, real-time transport control protocol. SRTP, Circuit Real-Time Transport Protocol, ICDP, Stream Control Transmission Protocol, ICE, Interactive Connectivity Establishment. Turn means traversal using relay, and stun, session traversal utilities for NIT. Firstly, we will give overview for WebRTC. We mainly talk about its realization on browsers. WebRTC provides easy means to develop web real-time communication applications. It's internally supported by modern browsers, so you needn't install any plugins. Basically, WebRTC consisted by 3 parts: peer connection, media stream, and signaling. Media stream and peer connection is internally supported by browser, but signaling it needs the user to implement it. Peer connection. Its function includes the following. It is used to build up connections based on ICE. Also, it negotiates for media capabilities and decide rules such as which peer act as controlling, which one act as controlled. In the user scenarios, we also call it as caller or calling. It's another rule function is used to send and receive media data, including audio data and video data. Also, user can send user data through peer connections. It's realized by peer connection data channel. Also, it maintains connection with the server and another peers. Media stream. Media stream provide high-level APIs to easily do capture and playback. It contains following parts: media capture. Media capture is consisted by audio capture and video capture. Media playback also it includes audio playback and video playback. Audio and video engines. It includes audio codecs, video codecs, audio processing like auto echo cancellation, noise suppression. Video engine contains maybe synchronization and image enhancement. They also include network adaptation functions. It is realized by JIT-buffer. Both audio engine and video engine contain it. Another part is signaling. Signaling is not a part of WebRTC core, but user can implement it through its own protocols, such as MQTT WebSocket. Its main function is used to exchange SDP, ICE candidates, peer certificate data between peers. Following diagram shows that SDP exchange process. Both peers send their SDP to the signaling server. When one connects in the SDP, the signaling server will answer peers' SDP so that they can use it to build connections. This part will introduce ESP WebRTC. Quite similar to brothers, ESP WebRTC provide a complete solution for WebRTC implementation. It consists following part: a WebRTC core and a media core. WebRTC core consists ESP peer and ESP signaling. Media core consists by ESP capture and ESP player. ESP peer. ESP peer provide an interface for peer connection realizations. User can implement their own peer connections. We also provide some default implementation named peer default for convenient use. This part shows that the interface. Maybe there are two ESP peer implementation like peer default and Amazon KVS peer realizations. The peer default support following features, and also it has some benefits. It supports STARM protocol, turn relay, SDP-based interface, and SDP integration, IPv4 support. We cannot support IPv6 currently, but we will try to support it in the near future. It supports multiplexing on a single UDP port. Currently, it supports retransmission using SCDP NAC. It also supports controlling and controlled, both rules. It has following benefits: lightweight, low memory usage, and it has few dependencies. Comparing with other WebRTC realizations, ESP WebRTC consists of less code, and it currently only depends on SRTP modules. Other modules is either contained in IDF or contained in IDF component registry. ESP signaling. ESP signaling provides an interface for signaling realizations. User can customize its signaling realization, while if he can use the peer default implementation. We also provide some default implementation for signaling for Google APP-RTC and Amazon KVS-RTC. Users can select and combine peer and signaling implementation to suit their real needs, such as it chooses peer default and APP-RTC signaling to build up APP-RTC app. Also, it can use KVS signaling and peer default for Amazon KVS-RTC app. The signaling interface is quite simple, like this. Security. WebRTC provides security realizations. We just realize it according to WebRTC protocols. It provides following security. Connection setup using DTLS. Currently, we use embedded TLS to realize it. Peer verification is done using SDP certificates, and the transferred media data is encrypted by SRTP. The data transfer over data channels is over the established DTLS connections. And also, we provide constant freshness to detect peer status, so that when peer is disappeared, it can disconnect it on time. Next part we are talking about is about ESP capture. We develop ESP capture for that. For the protocol part, ESP WebRTC, the peer default and signaling realization can suitable for any platform, but there are many device-related things like camera and microphones, and you need to do adaptation for it. We develop ESP capture for user to simplify the adaptation for a new platform. It supports following features. It supports a variety of audio and video devices. It abstracts capture device into common audio source and video source interface. Also, it abstracts audio and video encoders into interfaces. Through it, user can customize source and encoder through abstraction. We support stream out the basic audio and video data. It also supports access stream data into containers like TS or MP4. It supports streaming out the maxed data or recording it into local storage. Also, ESP capture supports multiple capture passes for stream data. Each pass can consist of different audio and video codecs. Also, it supports dynamic enabling and disabling of capture passes, so that each pass can work separately. Also, we add the overlay abstraction, means that users can mix their own UI into video streams. Here is the ESP capture architecture. We named one capture as a capture system. One capture system can have one audio and video source, means one microphone or one cameras, but it can have multiple capture passes. Each pass can have one audio and video sync. We named it audio or video sync, means that it has its own audio and video codecs. Also, we can add marks into each passes. For capture pass, we also provide two default realizations, one simple capture pass and one complicated pass, built up using GMF elements. The simple capture pass only consists one encoder, such as one audio encoder and one video encoder. It can meet most of the needs, while it consumes minimal resources. The GMF capture pass typically consists of two passes. Each pass can have almost the same capabilities. The input data is separated into two passes by a copy. the copy only copy the data, use the data point, so that it does not actually copy that. In the diagram, we can show that audio source goes through rate convert to change sample rate, channel convert to change audio samples, and bit convert to change audio bits. Then it is encoded by an audio encoder and output through the audio sync. This is a typical path. User can add its customized all the existing audio elements into it, such as audio EQ, AEC, and other modules into it. Video capture path. Video capture paths also, the data can be separated by a copy and transferred through video convert to change the color or the size. Then it can mix with the user overlays. Then encoded, such as HLUs 264, then output through the video sync. Now I will show the user scenarios about ESP capture. ESP capture is easy to build up following capture system. Basic capture for raw audio and video data, or the encoded audio and video data. Also, it supports stream out file 7 into local storage. It also supports stream out max data, such as some protocol may want TS stream data, so it can be streamed out through the max data. It supports capture multiple passes using different codecs or resolutions, such as one pass is used for stream out using H.264. Another pass can be encoded through JPEG. Also, we support capture camera data while mixing with customized UI, typically like add a time step into it. It supports image capture. Also, using the GMF concept, we can easily add other audio processing elements into the pipelines. ESP player. ESP player is used to play stream data or container data. It is a general player, so we just use it to play stream out that in WebRTC, but it can also use in other areas. It supports abstraction of audio and video decoders and renders, make it easy to adapt to different platforms. Now we can see the ESP WebRTC simple usage. User need only do some basic settings, then ESP WebRTC can be started easily. In the diagram, we can show that the user need only to configure audio codecs, video codecs, and video resolutions, including RPS information, audio transmission directions, like whether to send or whether to receive the audio data. For the signaling part, the default signaling only need the room URL, so we just provide a room URL for it. Next is the implementation for the interface or peer default and PSP signaling. After this, we can call API ESP WebRTC open, then ESP WebRTC start to start the WebRTC applications. Now, you can see that on picture there is a KVS demo. We successfully stream out the WebRTC data to the KVS peers. This part is we have also a demo video for ESP-IDF. Now you can watch it. It's quite a simple demo, and the P4 board is connected into a router using Wi-Fi, and we connect in through a mobile phone. You can see that the connection speed is faster, and the peak also, you can notice the video quality. It's encoded, use the hardware encoding, and the resolution is 1280 multiply 960. Also, you can see the encoding effect when we do some motions. The next part, we'll do some comparison with ESP-RTC. We already have ESP-RTC solutions. The difference is that ESP-RTC is based on the SIP protocol, while ESP WebRTC is based on WebRTC protocols. For ESP-RTC, currently, it does not support P2P connections. We also did not decided to support it in the near future. ESP-RTC uses SIP protocols for signal links, whereas ESP WebRTC can use any signal links. Another difference is that ESP-RTC transfers media data in clear form, while ESP WebRTC protects data at different levels, as previously mentioned. The choice, if you want to support P2P connection and also you want to easily build up web applications with a security cache, I think ESP WebRTC is the right choice. Finally, let me share some debug tips. There are two tips. One is on the platform part, another is on the browser part. On the platform part, you can typically fetch in server log to analyze it. Another thing is that you can also fetch network traffic data using Wireshark and filter user case during different stages. Like when check the network, the connection build-up issue, you can use case stun DTLs. And during the media data transfer stage, you can use RTP and RTCP to filter it. Another point is that we provide a PC simulation environment for ESP WebRTC. So you can almost use the same code and reproduce issue and fast fix for it. For broad part, you can typically inspect and check the console log firstly. Also, you can check the network traffic on the network page. Browsers also provide a special debug pages for the WebRTC. For Chrome, it means WebRTC internals. You can see the connection build details and the media data transfer details. Also, you can fetch network traffic data as mentioned on the platform. There are also some difficult things. You need to fetch some Chrome logs. You can look at WebRTC logs on the WebRTC logs page, or you can add the log of verbosity using the command lines. So this is all the things I'm talking about. Thank you.
And that wraps up the second day of DevCon24.
Yes, I believe we had some great talks today. We learned a lot, some deep insights, and a great audience for which we would like to extend a big thank you.
A small reminder about the feedback form, open positions, and the tomorrow talks. The third day of the conference highlights the amazing community that Espressif has. We really appreciate and enjoy the work done by our community, and tomorrow's DevCon is dedicated to showcasing some wonderful community projects.
Before we go, don't forget to like and subscribe to our YouTube channel so you don't miss any of these sessions. We will be back tomorrow at the same time as today, 1 p.m. Central European Time. The link for tomorrow's broadcast will be shared in the chat. You can also visit our website, devcon.espressif.com, for all the information. Looking forward to seeing you all here tomorrow.
Goodbye.